Good afternoon from the Ham Energy Institute, Oklahoma State University in Oklahoma City. We're pleased to be here at the National Academy of Sciences, Engineering, and Medicine, and our committee on, I'll just abbreviate the long title, Orphan Well Practices, okay? And what we're gonna do, we have a little bit of some preliminary introduction items. I'm sorry,
We're good. No, we're good.
And then we'll move into the session. So first, we're gonna start with just a summary of the study process, and Cameron with the National Academies is gonna provide that. Then we'll come into some introductions on the committee. By the way, I'm Jim Slutz. I know many of you, and I'm co-chair for the committee, and we'll get into introductions in just a minute. And with that, and then a little opening thing, and then we'll move into a couple sessions today, and I'll talk about our objectives today. But Cameron, you're ready for a little overview of the study.
Thank you, Jim. Thank you all for joining us today. My name is Cameron Osvig. I'm the Director of the Board on Infrastructure and Constructed Environment at the National Academies of Sciences, Engineering, and Medicine. My colleagues Noel Walters and Sam Kraft are also in the room from the National Academies. And we're so glad you all could join us. We have a large group online, and for those of the people in the room, I would like to apologize to our in-person attendees. We did ship off table tents and name tags so we could all know each other better. Unfortunately, and they were shipped to be here today. They didn't make it yet. And so we are going to have to struggle through kind of recognizing each other. But I think we'll get through that. So this is a study on the technologies and practices for plugging and remediating orphaned and abandoned oil wells and gas wells. I read the whole title, Jim. Read it out. There are two collaborating boards on this, the Board on Earth Sciences and Resources and the Board on Infrastructure and the Constructed Environment at the National Academies. We were tasked by the U.S. Department of Interior's Orphaned Wells Program Office on regulatory, technical, scientific, and economic considerations for plugging and remediating orphaned and abandoned oil and gas wells. And specifically, we were tasked with 5 actions to look at current and emerging technologies, best practices, equipment, and materials, evaluating unexpected or unique circumstances that would necessitate varying criteria and standards, assess available data on causes, frequency, consequences, and remediation of plug failures, post-plugging monitoring techniques, and then technologies, materials, and policies for future research. Our study committee is on the screen. I won't read off each name. We will do some introductions following this, but our co-chairs are Missy Feely and Jim Slutz. We have a cross-section of academic and industry expertise on our committee. And as I already mentioned, the staff here in the room. The Department of Interior's Orphaned Well Program Office provided us a recommended approach for our study charges. And I wanted to highlight that because it really is how the committee is approaching our study. In doing so, they asked us to assess the plug failure root causes. So what causes a well plug failure? And then knowing that, what kind of monitoring techniques would be appropriate for if you understood where or how plugs are failing, monitoring best practices, well plugging best practices, and then ultimately areas for research and technology to achieve permanent and reliable well plugs. The National Academy study process and information gathering. This committee is going to meet 5 times. There's actually going to be a number of intermittent meetings as well. So the number of meetings will be more approaching because we're gonna have shortened meetings 10. Any information gathering we have is open and public. There are 3 open public larger program in-person meetings, plus a number of shorter virtual sessions. In these public meetings, we are trying to gather information from state and tribal management of orphan wells, industry unplugging and abandonment practices, technology and materials research, monitoring research, and information on restoration. The committee is now in the writing portion of its process. We've been gathering information throughout the early part of 2025. This is another information gathering session. We are, though, in the process of beginning to formulate our chapters and our findings and recommendations. That will continue through September of 2025. And then that report will go to a peer review process at the National Academies and will be reviewed through November through January. Once that peer review is completed, that report will then be released publicly, and we anticipate that release in January of 2026. I also want to highlight some earlier work. This is task 3 of 3 task orders. The first task order was a white paper, which was a compilation of state well plugging and abandonment standards and procedures. That white paper was commissioned and compiled to discuss statutory and regulatory standard policies and procedures, methods, and design of plugging plans and requirements for well plugging activities. A link for that white paper is provided here. The other task that we completed as part of this process was a workshop that was held on July 2024. That workshop focused on historic and current well plugging standards and design, how these standards and practices may differ based upon a number of factors, considerations for cost, technology, and other factors that impact the development of well plugging plans, and environmental and economic benefits to well plugging and/or mitigation. A link to that, the proceedings from that workshop can be found on our website and on the National Academy's site. You can also scan this QR code if you're fast enough to do that before I switch slides. If you have any questions or comments, feel free to email Noel or myself. And with that, I will turn this back over to our co-chairs, Jim and Missy.
Cameron, why don't we go back to the slide with the committee members? Since we're going to do a little bit of introductions, that's convenient. And so we're not going to do real fulsome introductions of the committee, just letting you know who they are, kind of. I think Missy and I will do a little bit of brief introductions of ourselves just as chairs, but also a little bit on the agenda for today and tomorrow is our focus. So again, I'm Jim Slutz. As you see on the slide, I'm with the National Petroleum Council. I manage our studies there. I have a part of my career, which some around the room knows, involves regulating the oil and gas industry. Although my experience is a bit dated, I did that years ago. So that's why I've somewhat was selected to moderate today's conversation. And today what we're, our kind of focus today, you may have seen some of the state people and tribal folks have seen a questionnaire. And we did get some responses. We wanted this to be an opportunity to broadly talk through some of those issues. And then later after that, we have a session on monitoring both surface, subsurface that we wanted that is a part of the report as well. Let me just say overall what we're looking for is, the whole idea that we expect this to be hopefully kind of a dialogue system here today, because we're trying to, when we put that question, we're trying to say, well, what do we need to know? And so one of the things you might come up with is, well, why didn't you ask us this question? And that would be really useful as well. So we want that to be that kind of dialogue and get a little bit of nuances and stuff on that. So that's today, and I'll let Missy introduce herself, and then real quickly, I'll introduce, so people know who the committee members are.
I'm Missy Feely. I retired as chief geoscientist from ExxonMobil. And I'm one of the, with Jim, we're doing the co-chair. I'm gonna talk tomorrow. We're gonna talk about two specific things. One is predicting the well conditions in orphan wells and how do you incorporate that into risk analysis. And then also we're gonna look at new technologies that can be applied. And we'd like to have that dialogue, as Jim said, just a dialogue, and we're interested to hear what you guys have to say and what you're doing in your particular states. So
let me just, I'm gonna read off the committee, and by the way, all the committee members' bios are on the website, so rather than doing it, but just so as we go today, it's probably handy for those that aren't on the committee to say, well, who is on the committee? So, Jim Bolander, just kind of maybe wave and so people know who you are. Walter Goodrose is not here today, but he's on the committee. Tom Kropatch, which I know all you guys know. Jeff Landry.
right over there.
Okay, and Nathan Meehan. Nathan, I think you're online somewhere.
Yes, yes.
Yes.
I saw his face.
Yep, Adam Peltz. David Perrin. Maleva
She's online.
is online, and Ilis is online. And Mary Tang, did I miss Mary on here, or is she not? She's missing from our list, but yeah, but Mary was not able to join us today, but Mary's also on the committee.
She's in Germany, so.
Yeah, so, anyway, so with a brief introduction, before we jump into the session, I have a very important task. And that is to set the stage and clarify, there's a statement that we need to put on the record from the National Academy. So I will do this now. As one of the directors of the studies, I'd like to welcome everyone. The task being undertaken by this committee of the National Academies of Sciences, Engineering, and Medicine is provide advice to the Department of Interior, Orphan Wells Program Office on regulatory, technical, scientific, and economic considerations for plugging and remediating orphaned and abandoned oil and gas wells, which is indicated in the statement of tax that is posted on the project page. I would also like to give some sense of the format of today's meeting. We are discussing this statement of tasks with states and other regulatory authorities, assessing information and experiences with orphan well plug practices and well plug failures, and discuss monitoring practices. In addition, I want to note that this is an open, on the record session. Interested individuals have been invited to attend as observers. We will not be entertaining questions from the floor. I also would like to remind everyone that this is an information gathering session. That is, the committee is in the process of assembling materials that we'll examine and discuss in the course of making its findings, conclusions, and recommendations. Therefore, I ask everyone here today to be extremely mindful of the fact that the committee has made no conclusions and that it will be a mistake for anyone to leave here today thinking otherwise. Comments made by individuals, including committee members, should not be interpreted as positions of the committee or the National Academies. In addition, committee members typically ask probing questions in these information gathering sessions that may not be indicative of their personal views. The committee will deliberate thoroughly before writing its draft report. Moreover, once the draft report is written, it must go through a rigorous review by experts who are anonymous to the committee, and the committee then must respond to its review with appropriate revisions that adequately satisfy the National Academy's Report Review Committee and the National Academy of Sciences president before it is considered an official National Academy's report. Okay. Boy, we need that on one of those slides with the fine print. Say, that's the fine print.
You're supposed to read it at like 400 words per minute.
So,
I-
now, one thing I will say, there's in the room and online and I think we today's session's a little different. We said we're not gonna take questions per se. We are gonna take feedback and input. And so, and the other thing is we have quite a number of people that have registered online for today. And in time permitting, we want to give everybody a chance. We will endeavor to prioritize the input from state regulatory officials. So that just kind of an awareness, mostly for our online audience, that we'll try to, and so do we have everything lined out so we can figure out who the state people are online? Perfect.
Yeah.
So let me pull back my agenda. So with that, we're gonna move, any questions before on format or the day? I realized I forgot to cover one really important thing for the in-person. Correct. The restrooms are right through that door and you feel free. There's still, I think there's refreshments out on the table and up here if you need anything. The other thing is, and this is kind of my background, usually I started, we didn't incorporate a safety moment, so I will do that very quickly. And do that. We don't expect to be interrupted today, but if we do, our rally point will be at the circle, the traffic circle where you entered. If we have to, for any reason, exit the building, we will convene there as our rally point. So that's our safety moment today, because I was feeling a little remiss in not having that prepared, so it occurred to me. Okay, with that, we are going to move to our first session, which is very much a dialogue session. And the way we wanted to work this is to kind of work through the questionnaire. We had a few states respond, but like anything, a couple sentences probably doesn't necessarily cover that topic. And so if you're a state that did respond and you wish to voice over some of that, that's okay. I'm not gonna get into necessarily unless we need to cover the responses. But again, a lot of this goes toward the topic of one of the things we're charged with as a committee is looking at well plugging failures. And one of the things, just to let you know, that we're seeing, and we really want to get some feedback from states, is that there's not a lot of data to analyze on that, because it's just not, data's not, part of it's just the whole variety of challenges of the history of wells, but some of it's data and some of that may be, so we want to better understand that issue. So we'll just start with, we'll just start with some of these because they're more general what are before we get into failures, what are some of the key well plugging technology issues? That's one of our missions, is to look at what findings, conclusions, recommendations on directions that priority areas that, and it could be, is it industry needs to do more research, government needs to, what are research areas, not independent of who might do them. And so let me just pose that broadly. And if there are any of the state folks in the room that want to weigh in on that, and I can share some of the things that came in if that's a help for a starter.
I get started off right here. I'm Joe Gaboff. I'm the plugging chief at Pennsylvania DEP. Two of the big ones that really come to mind, the first one, and it's actually an ongoing issue and it's occurring right now, is just the nature of the geology in Pennsylvania. You have the southwest portion of the state with various coal seams and the degradation of pipe that occurs in those areas. So one challenge that we have is the pipe being rotted off. You have multiple strings of pipes, 2-inch, 4-inch, come out of the hole, and now you're looking at basically several casing stubs that we have to re-enter, whether it be milling, washing over, and it's different things seem to work on different wells, but the depth that those coal seams are at, 100 feet, 200 feet, just aren't. It's not appropriate to call an attainable bottom there, so we're forced to continue on, and sometimes we're looking at several months trying to address this issue. So that's number one, the coal problem. Number two, and if you're familiar with Pennsylvania, there's different well construction, so that would be an instance where you have surface casing and then open hole. On the 2 and 3 string wells, another issue that we deal with just because of the shallow gas formations, there's multiple, and they're in all parts of the state. The microannulus and channeling that occurs behind production casing, and sometimes we catch it before they plug the well, and we could develop a plan with the operator and try to address that. Other times, it's not there until after plugging. I've seen instances in unconventional wells where they had a wellhead pressure of 2,000 PSI, set a cast iron bridge plug to isolate the Marcellus, and you saw that production casing shrink, and now you have microannulus problems. So those are the two big ones. Kind of another one that's not so common is like a gas zone right at the surface casing shoe. And that plug is the hardest plug to set right at the shoe there, because as soon as you set it, late in that slurry's transition time, you're going to start seeing channeling through that plug, and that's probably the third one.
Others on technology challenges, or you?
Yeah, so is the attainable bottom problem only in coal seam areas, or is it elsewhere?
It's everywhere. It tends to be more frequent in coal seam areas because of that issue. It's extremely difficult to get, whether it be a 4-inch casing stub or you have tubing. And usually when they go to pull on that tubing to get out of the hole, it's bent that you can't get around it. There's very little you could do. You could mill on it, dress it up a little bit, try to wash over it, but it's just, from my experience, the success rate of getting past that once it occurs is very low.
And if you plug to a false bottom, what kind of problems might occur?
You could, basically set a cork in the well. I think someone put it best, and then you're pressuring up. I just think at a certain depth, it makes sense more to just vent the well if you could do it safely than, put a cork in.
Thank you.
For those type of wells that you described, what's the quantity of those? Several hundred, or it's just and I'll say that, and understanding how large the issue is, and is it translatable to the rest of the country, and as
Yeah,
far as prioritizing a solution.
I mean, I could think of about 10 offhand. I think
Okay.
operators, for the most part, if they know there's a situation like that, they'll avoid
Yeah.
talking to them, to be honest.
Okay, but are these modern day wells, or?
These are conventional wells
Sure.
in the southwestern part of the state.
So that could, other states in that area as well could be impacted, not just Pennsylvania.
wouldn't make that. call.
No,
No.
okay.
Well, someone online from New York has a comment, so maybe they have the same problem.
Yeah, my name is Paul Giacchetti. I'm the Regional Oil and Gas Supervisor up here south of Rochester. We handle 25 counties in central New York. Not all of those have oil or gas wells in them, but most of them do. Our problem with the orphan wells sounds just like Pennsylvania minus the coal seams. We have problems with shallow gas, and we have bigger problems trying to get to the bottom of the well due to the rotted casing. These orphan wells are 100 years old at times, even older. We've run into problems where there's actually been a sealed wellhead on the well, and we expect to be able to get to bottom rather easily. And unfortunately, that's not been the case. It becomes very expensive at some of these wells. If we don't get to bottom, we make sure we get deep enough where we're not going to impact anything shallow before we set plugs. But yeah, it's kind. I think we have the similar problems here. Not so much the gas zones at the casing shoes. We do cut and pull casing, especially if it's not cemented. We can seal that off pretty good. But our problem really is not leaking up the backside, because most of these orphan wells were never cemented, except for the bottom. You know, they weren't cemented to surface. We're having problems with, you know, pulling the casing, open hole plugs, and then the hole leaking. So pretty similar.
Thank you. Um, you know, one of the, maybe I'll mention briefly, and maybe, Jim or Greg may want to chime in, but just our scope on technology is, that we're looking at is very broad, looking at materials, looking at equipment, and also looking at the interface between well construction initially and plugging. So if there's any of those topics that and trying to sort out, you know, are we dealing with, you know, is it issue, you know, this whole issue of history, which we just heard from Pennsylvania and New York, versus, you know, looking and making sure current regulatory practices are sufficient, so we're not creating a problem down the road, because obviously that's part of the issue, is the, you know, just the construction practices that were done long ago. Before I'll we can come back and revisit any of these technology issues, but I just wanted to kind of point that out. We'll kind of keep moving along. Oh,
Sure, I might,
great, Tom.
I might chime in quickly on more of the technology side, and not necessarily the issues, but maybe an issue we have in using technology or adopting technology. And see if many of the other states might agree or not, but you know, we have various companies or people come and try to say, you know, we have a polymer, we have a new mechanical device, we have new cement type, we have new whatever it is, you know, it's gonna plug your wells better, it's gonna do this better, it's gonna do whatever. And I think especially on orphan wells, one thing we're hesitant to do is to try it. Because if it fails, then we've got to go back and spend more money to figure out how to now plug it appropriately. And generally, you know, accounting for issues you find in a wellbore, you know, whether it's, you know, fill or collapse casing or any of the other issues that can happen. We feel the tried and true method will result in a successful plug job if everything goes right, and if we can get a good plan, and if we can have the service company accomplish that plan. So I think we're hesitant to try some of the new technologies that may be appropriate, but you know, we're trying to make sure we're good steward of the funding we have to plug those. And so, you know, it might be wasteful of the money if we're not successful with the technology. So,
You know, that is a really good point, because I'm not sure where we have that on our radar of the technology regulatory interface. And that's kind of an ongoing challenge across the regulatory arena, not just upstream and wells, but it exists, you know, you know, across whether you look at pipelines or anything else. Is how do you know that new technology does what you need it to do, and how does it fit into the regulatory system, and how do you verify that? And I think that's an important thing that we should probably put. Adam?
So Tom, could you say, okay, try your technology, but if it doesn't work, you're responsible for fixing the well and you have to put up a bond to make sure that you actually do it.
Yeah, I mean, I think in certain cases, we'd feel comfortable doing that, you know, maybe we'd feel more comfortable if there's, you know, if it was an operator's plugged wells versus an orphan well. You know, the operator, you know, if they wanna try it with that, condition on it, we'd be more open to seeing what would work in those scenarios. You know, we may be willing to see what would work with some of these new technologies if they're willing to offer those. You know, those conditions on their own as well.
But it is fair to say some of these are, you want that plug to last for a very long time. So some kind of verification that the technology is going to be long lasting.
Right, which
I mean-
raises questions of what kind of plug failures can you know about immediately and what won't you know about for 50 years?
I'd prefer someone from a Wyoming standpoint, I don't wanna be the first one to do it. One of the, I'll follow it along after they show that it works.
But it's the same viewpoint on the operator side, right? And it brings a different perspective. I'm glad you shared, because from my mind, it's not so much any regulatory hurdles where, you know, rules say it has to be at TD or it has to be this, and it's too prescriptive, but if there's an openness and money was no issue, we do it, but is there some opportunity for collaboration? Not just US or with, you know, with operators, industry, and even worldwide. There's a lot of collaborative efforts in the UK and Australia on decommissioning and abandonment. We could look, you know, what would give us some more assurance that this technology, yet while new, has been trialed. We're not the first guinea pig, but if we can reach, you know, be able to gather that information and put that in the report, that help.
I think that'd be helpful for me, I mean, I think, you know, we'd be willing to accept that information from anywhere. You know, understanding what types of wells they're using it on and making sure they're corollary to what we have and the issues we face. Yeah, definitely would be happy to look at that.
And I think you wanna have a system where you can implement new technology, cause that's how you improve things. Let's see, we have Nathan first and then Jim.
You're muted, Nathan.
Nathan, I think you're muted.
All right, so speaking about the new technology alternatives, I think.
We're barely hearing you, Nathan.
Well, let me try to get over here. I had to, not only have I lost a lot of memory personally, but it turns out my laptop blew its memory today, so I'm having to use another one. The new technology issues we're discussing, and this idea of being able to use them on, some current wells. I think the bulk of current wells may be in a little different situation than a lot of our inventory of idle wells. So some of the newer ideas, I'd like to see alternatives addressed where we don't have casing in place, where we've got, difficulties getting bottom. These are the ones that are going to be high risk trying to put something in that I'm not, particularly comfortable if I was going to propose one of these, that's a likely spot, for me to have high confidence in. So this is an ongoing concern, how we test and evaluate these, and just I think this idea of let's let people experiment and bond is not going to encourage the kind of experimentation that we probably would like to get. That said, I don't have a solution there, but I do think we do need to do something that will encourage people to try alternatives that are promising, that could be widespread. A lot of the technology and research is going into in the well abandonment space, is going into horizontal wells or for carbon capture storage or for offshore. We're not getting, I think, the research effort that this could be. Part of it is, the cost structure, and part of it may be the lack of incentives. So it would seem reasonable, and I'd love to have your thoughts on that if anybody's doing something to encourage alternative technologies.
The question from Nathan, anybody want to respond on work that you're doing on alternative technologies or seeing done? We'll keep that out there and go to Jim.
I think, kind of listening to, some of the comments about, new technologies. One, it's, what is the technology? A lot of the discussion is around materials, as plugging media. And I think in that case, a lot of where we're gonna get information on that are from companies like Chevron who are out there, because they're gonna have the ability to do that. It may not be in an orphan well, it's gonna be in more of a conventional plug and abandonment situation in which, David's gonna come to Tom and say, we want to try this new material. He's gonna provide all the information to you and you'll evaluate it versus conventional practices. And then that's how we're gonna see some of that type of, at least what I see from a material standpoint. As far as I think what Nathan was talking about, we're dealing with a whole nother animal, whole nother type of technology of how do we get, clean out wells, how do we, reach from a Pennsylvania perspective, an attainable bottom, that allows us to meet the goals, that we're tasked to do. So I think it's twofold and, two different types of wells where we'll see different technologies used and why and who will be employing them.
David?
Yeah, so on the topic of attainable bottom, because I heard from Pennsylvania and New York, it's a similar issue. It's also an issue that comes up with in the CCS space where we may have to re-enter or remediate legacy wells of the same, that's in the area of review for where CO2 may be stored at. And while I think the subject of attainable bottom is good, it's also, it seems kind of vague on what you call that. I agree with 200 feet in a coal bed is probably not the right, you need to go deeper, but what we also heard in previous info, the well might be 2,500 feet and we got to 2,400, but we're gonna spend maybe, because the rules say TD and things like, so it's more just kind of getting perspective or appetite of, and that's one of the things that was passed from the scope of work on our statement of task is when do standards or rules should be variable for given conditions and should the objective really be, are we, while ideally in a normal well, we would get to bottom and isolate at the source, but is the objective protecting fresh water? What are the horizons we're trying to protect? And is there a middle ground to allow some cross flow risks, but not endanger USCWs or the like? So that'd be what I'd be interested in from a state issue. And is that a big concern on, varying requirements? And I don't know because I'm not, but is it a legislative act or how much freedom do most regulators have in varying requirements when certain instances occur?
Yeah, I mean, right now in Pennsylvania, it's pretty much a judgment call, it's the inspector and the field staff making that call if attainable bottom is appropriate. Ideally, and I know there's a section in our division that's working on this, or in our program that's working on this, is some sort of, based on the data we have and when those attainable bottom calls were made, what the geology is and some other parameters, like basically AI modeling that says, okay, in this instance, attainable bottom is appropriate at this depth. I think that's what we're looking at in the future.
Okay. And I guess one fault is also the whole principle of like minimum safe abandonment depth. Kind of looking at, if you have a confining zone that may have certain, enough formation strength, maybe that's the minimum depth we need to get a plug, and I like the idea of the AI technology and a risk-based approach to help further, add confidence on, can we stop here? So I don't know if any other states have similar issue.
Yeah, I guess I could talk to that. I'm Jim Armbruster, so I wear a few different hats, but for the sake of this panel, I'm Michigan's Orphan Well Program Manager. So similar to what Pennsylvania just said, you have to leave it open. There's got to be some discretion to use some professional judgment when plugging these wells. The geology is so, in each well is unique. You can't have one set of circumstances that you could write up that would work from one side of a county to the other, let alone from one state to another state. And you really have to evaluate what is the purpose of the plug job, what are you really trying to accomplish, which for all of us, I mean, I can't speak for everyone, but I would assume the ultimate goal is protection of USDWs. You want to make sure groundwater sources are protected, right? So when you're starting to look at where you're gonna plug, in your example, you said 2,500 feet, but you can only get to 2,400 feet. That might be perfectly appropriate, but it depends on the geology, what's down there, what formations are still open to each other. Do you really need that other 100 feet, or putting a plug where you are at, would that be sufficient? Because anything that's down there, even if it's cross mingling a little bit, does that really matter? And so you gotta have the freedom to be able to make those calls. You know, you're gonna have qualified people overseeing the rigs and overseeing the work, using their experience, using all the knowledge that they have locally in their areas, knowing what offsite or offset wells are like, knowing the geology of the area, knowing the goals. You really have to be able to have that flexibility, for sure.
And it's hard in my mind to set minimums like you're suggesting, because in those kind of cases, you're weighing a lot of options, like continuing to trying to advance, possibly milling out of the hole, creating additional conduits. And you're right, you're weighing, you know, you'd like to go deeper to prevent cross flow maybe in a couple formations, but the USDW protection is the prize. And so the team is always gonna, I mean, you could say it's good to have at least 20 feet of seal or whatever it is, but the reality is you're gonna go back to the information you have on that wellbore and have to make the decision, a cementing plan to put a plug or series of plugs in there to do the best you can.
Yeah.
Right, and even like in our rules, you know, there's still options. Your bottom hole plug doesn't necessarily have to be on the bottom. I mean, there are different ways to plug off the bottom. You're isolating it. You're not necessarily, that doesn't necessarily mean you have to put cement over it.
Yeah.
Right, so you could do it in that traditional way, or you could go, let's say it was a perforated hole or something like that. You could go above it, set a cast iron bridge plug, and then put cement on top of that and just leave that bottom of that hole, and that would still be acceptable.
Yeah.
You know, because it's isolated, and that's what you're looking for.
Yeah.
So it may not necessarily need to get to the bottom.
Yeah.
Ava, do you have a question or input?
It is question actually. Yeah. So there is a parallel, like you all of you, and thank you by the way for sharing generously all your experiences and information. That's very helpful to us. So mentioning geology and complexity and heterogeneity of geology and how, you know, we cannot really have a mindset one size fits all. That's talking about the past and the present. But if you add to this also the potential future cases and scenarios, like if in that area you're going to have, I don't know, CO2 storage, hydrogen storage. There is also a lot of talk, as you know now, about critical minerals extraction from these formations and formation waters. How does all that fit into your assessments and strategies, or are you overwhelmed with what it is that nobody really can think about the future? Thank you.
I throw in on that from Michigan. So this is Jim again. So to answer that question, if you're starting to worry about, you know, putting carbon or doing whatever disposal at a later date, right? There's an area of review in before any new well goes in, where you look at a radius from that proposed well location, and you're gonna look at all the records for old well bores, wells, whatever it is, to make sure that they are plugged appropriately before you would do any of that additional work. So they would get assessed a second time in that mindset, that they're not just plugged and then forgotten.
It's the importance of records and, you know, establishing the area of review, knowing what penetrations are in the area. So obviously, like Jim's saying, you have that record, you know that maybe that well went deeper, but it wasn't able to be plugged that deep. That's gonna factor into cross flow we were talking about. You now have to assume that this may be connected to that or that sort of thing. Like any other well that might need to be remediated, but ultimately, if that's a condition that can't be remediated and it threatens USDW or takes you to another level of seal, that's gonna change your evaluation of that reservoir, and the answer may be a no in that area.
I might just add just a little bit to that. I think if you know about it, if you know a project's coming or, you know, that it's a zone that is, you know, common target for disposal, for example, something like that, then you can try to plan for it. You can plug across those zones. You could, you know, even if it may not be normally required in a normal plugging rule, however, that well would normally be plugged. But it's also incumbent upon the future uses to look at what's out there and make sure that what their planned use is gonna match what's there. And so, you know, we can't just say, well, 100 years from now, we think they could be doing these things. You know, you can try to look for that, but it's incumbent upon the future uses to also consider what's existing and what does it look like, and you may not be able to do a storage project or something in that area because you may have wells that aren't, you know, or would allow cross flow or, you know, would allow migration out of their zone, and if they can't plug them to make it appropriate, they may not be able to do it.
And we've talked about that too, like it's hard to foresee all the possible reuse of the subsurface, but how much partnership interagencies, because you got one agency maybe doing the CCS permitting and doing that, but all the while the Orphaned well is chugging along, plugging wells, and hindsight 2020 would have been nice to put a plug here, knowing that we're evaluating a aquifer, you know, up shallower. So is there room for, you know, is that working? Is there room for, you know, improvement there, or, you know?
Well, I think that's important. So whoever the record keeper is, whether it's a state geologic survey, an oil and gas commission, whatever it is, I mean, the reason that these records are on permanent retention, or we're not allowed to put it on permanent, but it's 499 years and be revisited. So that's gonna take me past my retirement.
Right.
But, you know, and agencies communicating, and so I think, you know, that situation exists in Wyoming. Tom's good to speak with that, and Michigan situation, we're one and the same. We're the keepers of that data and the ones performing those areas of review. And we aspire to put data out for others. You know, that's the frustrating thing. Some people don't do due diligence. We had a convention center being built between an ice arena and a hotel, and they uncovered a 1872 mineral brine / oil well from lumber barons. And you know, that well was on our data miner. It was on our resources, and that well is exactly where it was shown, and it was 30 inches from the foundation of that hotel. And we swooped in there and plugged that well. But it was a dangerous well to plug. It wasn't leaking a whole lot, just a tiny bit of gas, but it had been disturbed. We didn't find much contamination on it, so we suspected the disturbance itself may have led to that. But that's an example too, you know, like attainable bottom hole. We didn't get as deep in that well as we would have liked, but we're working down in a 25-foot hole, 50 feet from an air exchange of a hotel underneath a $20 million convention center, and milling. And we got done, and you had to make the call to protect USDW.
Adam?
Thanks. So I was thinking about future proofing in the context of CCS, and I know that DOE has done a subter crosscut where they've looked at potential sequestration intervals. I think that's true. And I could imagine consulting with that when you think about what zones you want to make sure are isolated with cement. You know, I'm sure that the Permian Basin districts would have loved to have required cement through the San Andreas, for example, you know, before they started allowing shallow injection. So, you know, some future proofing is impossible, but some of it we might have data sets now. And I wonder, for the regulators, how do you think through those sorts of things?
I may jump in on that a little bit and also back to also the just who looks at what. They kind of touch on both of those. I think Wyoming is a state where our class 6 regulator is different than the Oil and Gas Commission, which is a little bit unique from what's out there right now. So it is a different agency that doesn't regulate, you know, the oil and gas wells that are typically, you know, the depths that these sequestration projects would occur at. And so we do have, you have to have a good working relationship and communication across those agencies to make those projects work appropriately. It's also maybe common in a class 1 UIC scenario with the same depths as well. So we have that, and you know, we publish data, but they can look at our data, but we also take it upon ourselves to make sure that the wells that we regulate aren't going to cause a problem. You know, they are required to provide copies of their application stuff, so we can know when those projects are coming in and we can look at those. But it goes beyond just looking at, you know, what might be there as far as AOR for orphan wells or other existing, you know, even producing wells. That we're looking at it also to fulfill our other statutory requirements of preventing waste of the resource, protecting relative rights for the mineral owners. You know, if they're proposing a project where there's mineral interests that could have economic production, you know, there's other conversations that occur there as well. You know, and maybe it's a little off topic, but maybe it should be a class 2 EOR project versus class 6 sequestration, because you're going to impact the mineral owners' rights.
Yeah.
And so there's a lot of, you know, these reviews and communications and things like that occur across the board on a wide range of topics, not just the orphan well scenarios. And I same thing for future proofing, or, you know, looking at those kind of things. It's trying to work, you know, geologic survey, he's looking at, you know, maybe a little farther in the future, for example, in our state on critical mineral production and other things, you know, hydrogen production. You know, there are people that are looking a little more into the future than what we might be in those. You know, you have to have relationships with those partners in all these projects.
So I'm going to take us a little bit into another area of questions, and you know, this has been a good opening conversation, so we're going to take on the hardest part of this, okay, right now, because it's the part we really need to have the best, you know, kind of a lot more dialogue with the regulators about. And one of the questions was collecting data on plugging failures from previously plugged wells. And one of our tasks is to try to analyze you know, root cause analysis, plug failure stuff. But in order to do that, you have to have pretty good data, and based on the responses to the survey. And it was a small number of responses, and what did not surprise us, we felt it was a challenging thing, is that we don't have a comprehensive data set to analyze to say this is the, you know, percent of well failures that can be attributed to this failure or this, and so we're, as a committee, we're struggling with how do we be responsive to that request, which is a very useful, you know, and we know there's some research work, there's analytical work, and we're compiling a list of these are the different ways that you have failures. And I think at some point, once we get that compile, you know, fully, you know, kind of put together, we probably might want to have another round to see if we're missing anything that you guys know of. But then as we look at kind of trying to address that and evaluate it, you know, again, there's the audience for this is, you know, like all of you, which it's a very informed audience, but there's also audience that are less informed. And so how do we kind of convey and explain those types of failures? And we're thinking that it might be useful to, you know, once we have a list of types of failures, what are some anecdotal examples that would give kind of the background story of why that fails in that case. You know, sometimes much of it is issues with history and other issues that don't, and that leads you to say, well, why does the system now fixes that for new wells and those kind of issues? But then it raises the issue as a, you know, we look, and we don't want to create a lot of burdens, but we're like, well, maybe there should be some data, some additional data collected and compiled that could be used in the future for evaluating this. So that's kind of the intro to try to start a discussion about this well failure issue root cause analysis. One, that I've given you just a really high level thumbnail of how the committee's trying to get our arms around it, but really would welcome some thoughts on that and thoughts on, part of the issue on is it in the existing, is it like, for instance, on data, is the lack of data an issue of that it's just not being compiled in a way that it could be collected, or it's not, we're not doing enough follow-up, or we would have to do a lot more monitoring? There's all sorts of questions about what data you would need, and is it data that we're just not getting into the system now, or is it, and then you have the historic challenge, because if you have a well plugged in modern times, and that fails, you have a lot of records and data on it. So there's some of, and just because when you clean out a well, you may not exactly be able to tell exactly why. So that's just kind of just trying to frame this, and would really like to have some good dialogue with the states on this particular issue to help us try to figure out how best to proceed and what's the most useful way. And does that, and I'm gonna ask my committee members, have I teed that up for the discussion? Am I missing key components? And Nathan, you have your hand up first.
I just wanted
your
to
input.
add, I just wanted to add a little bit to that question. At some level, asking you for that data presumes that on some regular basis, we go back and monitor the wells that have been plugged. And I'm not sure, to what that extent that is. I'd love to hear from you about what are the circumstances that prompt you to go back after some period of time and check on prior well failures. So is it just when there was something problematic? We know from our future, our friends to the north, that they have in many cases some very routine follow-up, like 6 months, a year later, to actually try to measure vented gas, whether or not there's still ongoing leaks before that plugging is finalized. I don't believe that's the case in many places here in the States. So what we're assuming that maybe there are some checking on these, rather than just saying the only failures are catastrophic failures.
Okay, thanks. Hey, Ilis?
Yeah, so just maybe as a follow-up, because I think we've had this discussion, and even earlier this morning, that if you wanted to go back and, like, if you did do monitoring at maybe with some wells or some portion of the wells, you'd want, in order to really assess why you're having failures and why you might have issues with certain wells, it'd be really important to collect data about the well plugging process, the materials that were used, things like that. So I might maybe, like, part of that question is like, what would make it easier to collect that data? Like, maybe a nationwide database, or some way to upload the data. But if there's ways that would make that process easier to either collect or to submit, I'd be interested in hearing that.
Okay, thanks. Let's open it for some conversation, and then there's probably some further, input from the committee at some point here. Anybody wanna, and Tom, can I pick on you maybe to kick off on some of that? You're part of the committee, but I think you're in the middle of that role, and I think you've been part of these conversations about trying to, how do we get our handle around that?
Sure, and I probably won't be able to, I'll probably forget half the questions that are circling out there, and maybe we'll have to come back, but maybe to start with some of the last questions on monitoring and data reporting. We do collect quite a bit of data or database, quite a bit of data related to well plugging. We have the material types that were used, where the material is, whether it's a bridge plug or cement retainer or other things, what depths those are set at. We have data on the whole procedure, essentially. Materials used, where they're set, what the requirements were, all the information from the service company on their daily logs or rig reports or other things like that. So there's data there. Some of that, and every state's going to be different. A portion of that is database where you could utilize the data. But a lot of it is on paper, especially if it's coming from daily logs or things like that from the service company. They're writing out notes and then they're submitting copies of those to the state along with the information. So, certain things are database and certain things aren't. And some states have robust databases, some have less robust, and some just have a lot of paper files. We don't, in Wyoming, we don't go back and monitor at all. So the way we find out, in some cases, maybe some states wouldn't call this a plug failure, but if you set a plug and it's got, some gas migration through it while you're still plugging, you sent more cement, maybe you'd go back, maybe you'd make them drill that out or a portion of it out and set something else. So some of those are found during drilling. So whether that's a plug or during plugging, so whether that's a failure or not, I don't know. It's probably not, because the well's been plugged successfully, we think, when we're done with it. A lot of our, if we have some, which, the way we find out about them many times is a landowner will call us, a rancher will call us and tell us that maybe there's some water or something coming out of the well. And so we go back in and look at that, but.
I hope this is helpful, but I hear your question in like 3 different ways. And I think, Tom, you're trying to answer all of them. So there's just that, there's the failure of the plugging job, right? And I think that we have pretty good data on when that happens. Then there's sort of the wear and degradation of the plug over time. I think in other states, and my own, certainly jump in if I'm getting this wrong, we have less information about that. And that is complaint driven largely, right? We get a complaint that something's gone wrong. It's years after potentially the work was done. And then I also heard you ask about sort of this historic wells and the issue with them leaking. And I think for those, that's really probably a combination of both, that the standards for plugging were very different at that time. They didn't hold up. Or that the record keeping is so poor. Perhaps the regulation wasn't what it is today, so nobody actually checked to see that they were in fact plugged. I think there's a lot of, that's a very noisy set. I don't think you're gonna get a good handle on that. But I think that the first set, we probably have good information on. Because like Tom said, we have the records of what we did. And we're likely to go out at some close time period and check to make sure it's not leaking. But the second set is gonna take, I think, a while. I think for us with state funded projects that have been going on for a number of years, we could probably start to see some of that degradation at this time, because we've got enough time has gone by. But I would still say that data set is going to be pretty thin, I think, and largely complaint driven. So your wells that are in more populated areas, perhaps it might be biased. I just offer that as a way to sort of break.
No, and I think that's good, and because we've actually sorted through all those same kind of, issues about, boy, that this historical set is just a historical set. And the history is very different in different parts of the country and has a different look. One of the things, let me take this to another that I think is where when the study was, this particular section was spec'd, was was the whole idea with the root cause analysis is how do we know that our current set of well construction and plugging standards won't result 50 years from now in a whole new set? How do we know that plugging is durable? And so part of that is understanding how wells, how these failures happen. And so I think that's part of where this, it's not just, it's failure and kind of root cause analysis is kind of the tasking. And so that's where we're looking, is there a way is there a data set we could start collecting now? So even if we don't know now,
I mean, it
in
might,
10 years from now or 20 years from now, we could have a greater comfort level. And our recommendations might say, this is the data set that we should start collecting.
it might be by getting more information about those wells that have been plugged in, modern times. And trying to beef up that, because to my mind, that's the weakest. It's the weakest data set, but it's one you could know. We do have records about what was done. And, I just think we don't have the follow-up. I mean, I don't. Check Nick Paul has his hand up. Sounds like I'm doing.
And just like when I offer these kind of ideas, I want the committee to feel free to say, Jim, that's not what we talked about. And this is what we did. This is where we want to go.
I'd like Julie maybe to chime in here, because Colorado may have, or you might be one of the only states that actually has the requirement to do some follow-up, even if it may be very early after the well plugging. And some of, when we're talking about hundreds of years of hoping a plug lasts for several hundred years or more versus what you guys do, but would you mind Julie chiming in on that?
Totally, and I apologize for being late. Been a big media day in Colorado, which is never a good day for me, but so I think that we've done a couple of different things. We do have kind of follow-up monitoring on the methane side for orphan wells that have been plugged. But it's more in that like days range, right? Kind of consistent with some of the guidance that's non-regulatory from Interior on that component of it. But the other thing that we have done is we also retained Colorado State University to perform a measurement study to understand emissions from plugged wells. And also this is like feels very colloquial, but like also the unplugged abandoned wells, right? So the plugs we had, the wells we had not yet plugged. To understand what that looks like in this context. And so we do have some data from that, but it's not comprehensive, right? And the legwork to actually get a comprehensive review requires a lot of effort, right? You've got to secure access from every single landowner. You've got to do all these things. And so when you start talking about like, what would it take to monitor, my head spins from a cost and logistics standpoint, though it would be perfectly wonderful. And in a perfect world, it would be great to go out and survey and get that data and then to collate it to understand what were the plugging requirements at the time? What data do we have about that? Because there is a huge time component with all of these questions, which everybody's nodding heads tells me that I'm telling things that we all already know. So I think I'll probably leave it there if that's all right. But we have a start on it, but we don't have the ability to fund that in the long run either. I think that, it's interesting for those folks who are looking at carbon credits and what that regime will require for long-term monitoring may start to provide some of that data in the private space, right? But that's not today, so. Was that, did you?
That's perfect, yeah.
Thanks.
So Jim, you wanted to add?
Yes, kind of what I wanted to ask on this one in particular is, since we're finding that we don't have a lot of data or it's minimal data, and, I appreciate the comments on, when you're plugging a well and you have a plug that failed, you're gonna remediate it during the process, and have that kind of information on what caused it to fail and such. But one of the other underlying issues is data that we have on active wells, barrier failures. I know Colorado has a robust program on break and head monitoring. And plugging wells kind of started in a geographic area, and now it's moved to the state of having that data. And not just having the data on the measurements, but, you know, what's causing it. I know in the Wattenberg field, you know, they're getting a pretty good handle on what the cause is. And I know in Pennsylvania, y'all, you know, have your vent flows and gathering the data there. You know, I think that can help us, you know, along in some of these areas as well, is, you know, as we're looking at failure mechanisms, is, you know, was it not a bad cement job? It was just the cement top wasn't brought high enough. You know, we should be able to correct that in a plugging, but, you know, it may be a flow zone that's not productive, but it's gonna give you problems. You know, I know some states, I think Colorado requires, you know, those zones to be plugged. I know same with corrosive intervals. Texas has that regulation, as well as knowing ahead with what you're saying from some of the active well barrier failures, how it can help, you know, predictive on the plugging side as well. So what do y'all, I mean, I guess trying to interact with, you know, do you have data on that, and, you know, what type of causes that have you seen from some of that data?
In Pennsylvania, all the data's there. It's just not in a usable format. You know, a lot of the plug failures, they're documented in an inspection report. You know, it's there. Someone could probably go through it and say, okay, on this well, there were these parameters, but I think it would be useful to have a data set where you figure out what parameters you want to use, whether it be casing depths, TD, gas zones, cement use, type of cement. Then once you have all those parameters, you could, you know, run like an AI modeling to see if there's any patterns in that data that maybe we don't see, maybe, you know, just something that we're not seeing. Then you could look for patterns and say, okay, if we set a plug in this zone under these circumstances, it has this percent likelihood to fail or something like that. I think that would be useful. It's there, but just not right now.
David?
Yeah, so I guess question in some context, because this is the hardest thing that we're trying to wrap our arms around. Because the way the department entered framed the questions, you know, or the reason they're asking this is lunchtime. You know, given the $5 billion we're using on this, it's sensible to explore how permanent the work is likely to be. So it's almost as if they're looking at all these orphan wells that we're plugging today. Is it going to hold up? And then look into the past on the handful of wells that do leak, but it's hard to quantify. Is it a handful without knowing? Is there more than a handful because we're just not looking? So, you know, but at the same time, the handful that we do know predates modern standards, so you shouldn't be judged to that standard either. So it's just a whole lot of things to try to unpack. But at least if a point forward going, from what's done is done, at least for the 100,000 plus wells, we still got a plug going forward with the orphan well program. Is there a mechanism to at least, instead of saying it's just a handful, but it is these 10 wells, and then we got those 10 wells, and we can now look at what we did and say, well, it's because we didn't go put a plug in the B and C annulus, which, you know, or, you know, we didn't put a plug even, we used too much of cement, or, you know, how we can then draw down and understand really, we all have general ideas of failure mechanisms on why things happen, but it's really hard to get evidence-based without the analytical data. And, you know, so what's done is done in the past. It's hard to, you know, past performance to dictate future performance, but if going forward, can we put some, you know, ease of mind to the public and all, is that all the plugging we're doing today is not gonna, you know, resurface issues at a later date too. And it goes back to, I think, the guidance that you mentioned. So that's really my question here, and I think I know the answer, but the guidance being, well, we'd recommend you go back and look at least 5% randomly. Now you know, Colorado yellow days, but not a year later. Does anybody do the recommended guidance? And should we, maybe not 5%, but be, just some sample size? And that's really what I wanna, not to cause any kind of debate or not, but just really getting perspective on that. So it's a chicken or the egg thing. It's hard to say it's a non-issue when you don't study it, but then to study it, we gotta pay a lot of money and site access, and so where's the balance?
Yeah. Can I answer something? I gotta say, this is not a full-on criticism, but you guys are asking more questions than you're letting us respond. So we now have a 15-point compound question here, but I would offer you perspective in this space. From Michigan, over 60,000 holes drilled, and a good almost 40,000 of them predated the 70s, where we have kind of our more current, modern requirements for plugging. So you can think of 2/3 of the holes in Michigan probably fall into that old heavy mud bridge plug stuff. And yet, anecdotally, as was mentioned, we have very few problems with those. I would say every year, couple of years, maybe it's 3, you have an instance landowner is saying that there's something flowing in their field. Now, maybe that, was never plugged, but more often than not, maybe that's plugged with heavy mud. And I think to answer your more recent question before I forget it, is anecdotally, we've thought through this in cases. So like, why do these things get disturbed? Sometimes they get disturbed because there's a water flood in the area. And we've thought about this in the context of the Orphaned Well program, that, we're trying to plug the wells that we have in Michigan that are orphans. But we've wondered in the later parts of this program, we're not concerned about finding tons of undocumented wells, but where we've found fields where we've had these problems of like where there's been a water flood and things have popped off, is there certain formations, is there certain fields, plays that are higher risk for that mud? Because we think, heavy mud and the stuff they put down the hole generally does a good job. In many instances, we don't see the problems with it, but we think that maybe if there is additional work or things that we want to look at, where have we had those mud plugs disturbed? Is it just because that formation is given to repressuring? Is it because of a water flood? What was the cause of that failure? We don't see a lot of them. Like I said, anecdotally, it's every year, 2, 3, it skips, things like that. Yeah. So I probably lost the 8 questions in between there, but no, I mean, we have thoughts about that. We can probably talk to you more. The data sets, like you said, yeah, the data is probably there, but it's in flat files. Like, I mean, the process is there when you're setting plugs, you're bumping them, you're waiting for, like there's a number of reasons why a plug could fail. And again, you guys asked a lot of questions there, but it went back to some of the zones, like you were setting plugs and you had no problem. In that well plugging operation, everything was set under static conditions, but then the final plug did show failure and gas cut. Well, why? Well, we don't see that very often, but when it does occur, sometimes it's that instance of a shallower charged up zone. And, now I'm talking like one of the other questions over here, how can we do better in the future? Those are the kind of things that you evaluate, right? Like in a class 1 mineral well or a class 1 UIC well, it's all string cemented to surface. And it's supposedly like the gold standard and everybody loves it. But there's also a second school of thought where you don't cement everything to surface because you like the ability to remediate downhole conditions. You like the ability to monitor annulus pressures. You like the ability to rip casing, pull things out. So maybe that is a space where this group is thinking through some of those, knowing that now that we're going back in and plugging old orphans, you're seeing zones that have eroded through, corroded through. Those are the kind of issues that do allow dump flooding or problems. Is there a best practice that comes out of there? Like, you know, it's two schools of thought, but is the one school of thought, the advantages gained over here just not worth it because you know what I mean? Is it all strange set to surface is the best thing?
Right. No,
There's pros and cons and you know, you ask a geologist, 5 geologists a question, you're gonna get like 6 to 10 answers, right?
I understand, and that's the hard part is we're being asked these questions, we go and relay it to all of y'all, so it's a lot to unpack, so I don't mean to bombard y'all with questions.
No, that's all right, that's the best I could answer your 14 questions.
I would like to add just a couple things to that, actually, it was well done, but, as our field operations section manager, one of the other hats that I wear, I oversee all plugging that happens, and not just orphan well plugging, all active operators and all that stuff, so to hit to Tom's point, yeah, we do see plug failure on occasion, right? But it's not well plugging failure because we're there and addressing it when it's happening. When we don't move off the location, nobody moves off that well until the well is plugged appropriately and it's not leaking and USDWs are protected. And there are a number of ways to do that during plugging. Like Tom said, you can wait, you can tag plugs, you can monitor fluid levels, you can check. There's a lot of different things that you can do to make sure that your plugs are in place where they're supposed to be and that they're building their compressive strength and that they're gonna be adequate. As far as, you know, your question, we're heading towards some sort of guarantee almost. Nobody can guarantee you that a well's not gonna leak 200 years from now. There are no guarantees in life, right? Other than we're all exiting at some point. So, other than that, I mean, nobody could ever tell you that it's gonna be good 200 years from now. I mean, no matter what you do, we could fill it with, you know, mystical powder. That's like this amazing thing that it won't matter. Nobody knows what's gonna happen in the future. What I can tell you as far as when we do see, to Adam's point, when we do see something that pops loose, which is very, very rare, extremely rare in Michigan, it's never what we would consider a moderately plugged well, right? It's nothing from 70s, 80s, 90s up. It's always older wells, where we see if something happens. And the fact that we don't see those issues now, I mean, those have been in place for 50 years already. When you start thinking about it, those cement plugs are already 40, 30, 40, 50 years old. So you do have more data than you think you have. If we had significant, even moderate issues with plugs failing and all, we would have calls. There'd be so much stories in the news, like everybody's, you know, water, this and that, and you don't see that. And I think that that's anecdotal, as you might want to, as we might call it, but I mean, it's still data.
It's anecdotal, but we got 60,000 holes across Michigan and we got 2.6 million water wells. With a large percentage of our population drinking off groundwater, and like Jim's saying, it's anecdotal again, but the phone would be ringing like.
Right,
every
and we need
day.
it on record, that's what.
Well, you know what, but I think this is a really valuable point, and maybe there is a way to look at it, maybe there is a way to evaluate it from a more data-driven perspective, and that's looking at the, you know, and maybe this is a data point that's actually available, and that is if it's possible to look at on a state-by-state basis, you know, what was, if you look at your orphan wells that have been plugged, if there's a way to do an analysis that say, you know, 99, you know, whatever significant percentage are actually in Michigan, we've identified that 1970 is the cutoff, you know, the cutoff year, or 1975 or 85. And X percent of the orphan wells we plug are these older historic wells. And that is real data.
Exactly.
And it may not be, you know, we'd have to figure out how to look at that and write it, but maybe it's a conclusion that said this is primarily a historic problem.
I have my own conceived notions, right, that can lead, but so my follow-up question is, anecdotally, even when we do get the phone rings, it's a historic pre-1970s well. Anecdotally, how many, at least in the modern day era, orphan well that we're plugging? Is it zero? Is it even less of a handful of calls, you know? How do we judge that? Because that's what I want to, you know, whether that's the conclusion or not, is we can really chalk it up to historical practices versus, but we're still using cement, but we're better and things like that.
We've done 400 wells with our orphan well program since 1996, and to my knowledge, we've not been back to a single one
Okay.
to replug them, no other problems. And to one of your other questions, you asked about 5%. I mean, this is labor intensive if we're gonna go back and review things or even day forward. And I do suspect that a reasonable population sample is the way to go, a spot check. And I think that a requirement across the board would probably be pretty burdensome on both industry and regulators.
Yeah.
My head also started to spin when she said, her head was spinning, my head started to spin too, like thinking about the logistics of trying to go back to properties 10 years
That's
later.
in their guidance currently, right? Just no one really followed, you know, and so that's it. No, I appreciate that.
I think what you might wanna look at isn't necessarily, I mean, one thing that you could look at is how many wells are being replugged.
Mhm.
You know, not something that's not an initial plug, it's a replug, because if it was a replug, then something occurred. Now, it may not be a failure, maybe someone's going back in because they wanna do a project that requires the well to be repaired or replugged.
Yeah.
Able to do that project, but, you know, a plug failure means it's been plugged once and now it's being replugged. And that's maybe the data that we should point towards to say, this is the subset that we should start looking at, because must have been some issue with the original plug.
Yeah, and that's really where I'm going with is exactly that is, I think, you know, we haven't defined that yet, but that is a task of this, is how do we reach consensus on what is defined as a plugged well failure? And to me, you know, if you gotta re-enter it, that seems like a failure to me. And how do you count those? Cause right now it's rare, but you know, by saying it's rare, I think that's good enough, but if going forward, we had some way to track that, or, you know, would that be a preferred recommendation?
I mean, in Wyoming, it'd be easy to track.
Yeah.
In the future, like, okay,
Yeah.
this one was already plugged, now we're going back in to plug it again.
That way we have data.
Historically,
to-
it's a little
Yeah.
tougher to maybe sort through the database and figure out which ones were plugged as re-entries or which ones were not. But
I'm a big fan in day forward things, cause sometimes there's not a lot we can do about the past, but if this body came up with, you know, 5 to 10 metrics that are important for us thinking about this problem long-term, that when we do have a failure, or, you know, hey, we get that landowner calling to say that something happened, that we start monitoring the root cause and you start to see patterns. It could be a nice data, you know, body of data, very useful moving forward. And Catherine and I were kind of discussing, states do modify their construction methods. There's no doubt that we've gone back in and saw ratty cement, looked at CBLs, you know, you go into a re-entry. That's not to say that even with modern cementing, that you don't go back in and find some zones where you can basically almost wash through that cement, but there may, you know, there's not also a problem there necessarily, but states continually reevaluate their casing plans. Would we issue a well with the same exact casing program and cementing program that we see, that we did in the 30s or 50s, now that we pull things up, maybe see where the sour zone has completely dissolved them? I mean, we're thinking about those things and making companies, you know, where maybe there was an intermediate casing exception in the past, would be like, you really don't want to do that, because you want to cover this formation, because it's going to eat right through your well and you're going to end up having a problem.
And that's data driven in itself, right? You continuously improving standards due to whether it be anecdotal or something, we have some type of causal that has led us to beefing up standards, so.
I mean,
Go to,
I mean, Colorado's plugged roughly 700 wells, orphan wells, since 1990, and within those, we do track which ones were leaking, that's how we prioritize it, but what we don't track is whether they had a plug in them. Or like, if you're talking about data sets and desktop reviews, right, like if you can pull the wells that have been plugged in an Orphaned well program, and then you're looking at 700, not 100,000 wells.
Right.
Right, and that could start to hone in on what that is, but again, the variable being how was the well originally drilled and constructed.
Right, there may be but you could look at those 700, say, and
Right,
say these are,
right,
608 of these were drilled before this date, and that's, before our current
Well-
modern regulatory era kind of thing.
but even still, like, we're tracking what had a leak from those, so of the 700, roughly 350 had a noticeable leak, right, and we're using, and so like, now you're like.
Now you're into 350 because that's,
Yes.
A little bit more doable.
Yeah,
Right. Not 1890, we're going back to.
Right,
Yeah.
and then like.
Paul, we'll get to you in just a
Sorry,
minute.
but even if you like bridge that out into looking at what other failures are, because we've had to go back. I mean, we had a well control incident from a well that had been plugged. Prior, the well control incident was December 23. Right, and it was an inadequate plug job, they thought it was a dry hole, so they don't think they adequately plugged it, it failed. Neat, but those kinds of questions, right, like, and like, I guess with the information you gathered from Orphaned well program, you could look at similar situations across wells that were plugged, not in the Orphaned well program, to see how those wells are faring or not.
Right.
And maybe be able to access surface differently from a single operator, too.
Much more manageable
Kind of, yeah.
task, and whatever we can grab insights that will help.
And like, and I'm sorry, I missed the beginning, it's like the overarching goal to like help articulate what we anecdotally know that for the most part, plugs that aren't failing, or is it to be able to like say, these are the ones that are likely to, so we should focus attention there, like, or is it, we're trying to work through what the right question is,
We were tasked with,
which.
what is a plug failure, failure rates and failure mechanisms, and of those mechanisms, what is the rates? And that is what has led to these data questions, which we kind of all are not surprised. Don't really track a lot of that, and it's labor intensive, but trying to drill down onto it to put it in, like I said, to be able to communicate to them is, while we know anecdotally, or there's enough case studies that it's not zero, there is a number greater than zero of wells that have failed in the US. Of that data set, is it due to being pre-1970? Probably most likely, or before changes in standards, but how can we, that's a pretty strong notion, but can we definitively say that we've already changed our standards, so we're not gonna have these, it's rare to begin with, and it might be even more rare going forward, so therefore spending $5 billion of federal money is still a good steward of money, and we're not kind of, perhaps gonna see a rash of it, leaks in the decades to come. So at least that's how I interpret what DOI has asked us for, and but how do you come to that conclusion in an evidence-based manner?
I think that's well framed up, and part of it is what is the right we've been asked this question, is it the right question to ask, or should we reflect back? Yeah, that's a great question. This is the question that.
Yeah,
It's a loaded question.
but it seems like if you narrow it to like orphan wells have been plugged by regulators, right? You necessarily have a cutoff in time where plugging practices are better, right? For Colorado's 1990, it sounded similar for Michigan. Looking at more modern plug jobs, right? And defending the program as it is today and not trying to defend them.
Agreed. Not, because I think it muddies the waters of, if you have a well from 1950 leaking, then that gets, applied to universally, all wells could have that failure. And that's not necessarily true or not true until we can show that. And that was kind of the intent of the survey question, is at least for the wells that under your regulatory control as an, orphan well, we may be able to mine that data better.
So let me go to Paul from New York.
Thank you, Jim. I hate to throw a monkey wrench into this, but I will anyway. It'd be interested to know what the other states do. Once the well's plugged, what do you do at the surface? I know in New York State, we cut and cap the well 36 inches down. we could go back to every well site. We wouldn't know if it were leaking or not. I mean, it could be leaking into the groundwater, but no, surface expression of that leak would we be able to detect. So, that's something I was just interested. I know, I believe in Pennsylvania, they fill the casing from the chute plug up with gravel and put a vent pipe in it. Obviously, that way, if it leaked, you would know it. But I don't know how we would do that in New York without digging up the well and exposing the casing.
Yeah,
Go ahead.
well, Pennsylvania, you basically have three options. So in a coal area, and there's a distinction in our regulations between coal wells and non-coal. Coal area, you have to bail it dry above your chute plug, place a vent on it, a 72-inch candy cane, and that's basically that. If there's any active mining going on, gas is gonna go the path of least resistance. That's part of the Gas Coal Coordination Act. For non-coal wells, you could do a vent pipe if you want, most don't, and above the ground monument, or you could cut and bury. And I would say for non-coal wells, probably 80% are cutting and burying them.
I'll just add to that. So it's interesting that you just brought that up because I literally just talked about that with like 30 of the states 3 days ago. So I ran at the IOGCC's conference, I just ran the inspectors forum. And we had, I don't know, 25 states represented there. And one of them brought me a pamphlet from West Virginia and it showed how they put monuments in and they leave their casings 4 feet above ground. So I went around the table and got what it was doing more or less. And it was about a 50-50 split between the states on who buries the casing and who leaves monuments. Now, the monuments aren't always on the well. Turns out sometimes if the well's in the middle of the field, then they'll move the monument to the edge of the field, but with like a lat long put into it so they know it's out in the middle of the field, right? So there'd be no way to access that, like Paul said. In Michigan, we cut and cap 4 feet below grade. And I think the expectation of that, like you said, is past path of least resistance. So if it's coming up, I mean, you could probably still measure it at the surface, even just doing a laser survey of some sort at the surface. But then again, now you start getting into the logistics of how are you going back to somebody's property a year, 10 years later, whatever your monitoring plan might be, and say, I'm some random, state person, I'm gonna come run this meter all over your property, like that's not good. Yeah, trust me, I'm from the government and I'm here to help. But anyhow, as far as the wellhead stuff, yes, about half the states leave it above ground and half period.
I was glad you said that. It's a really important point about the behavior of gas going to low pressure. It goes up and it goes to low pressure. So I mean, it finds well points and surface puddles right around it. I mean, you got puddles in and around an area, it becomes obvious if you've got an issue there, right?
Well, I have a simple one, maybe. So, when you discover, well plugging failures, is it because of water? Or is it because of gas? Or is it because of everything around the well is dead? I'm like, what's a
It could be
proportion
all
of those?
those, yes.
Is there, are any more preponderant than others, or do they all just appear and it's hard to say which is the greater indicator?
Stressed vegetation and fluids to surface is a pretty big one.
Yeah, and they typically almost always manifest right at the well. It's not, you don't usually see them out and away someplace. Like if you find it, you pretty much can. And because we bury ours in Michigan, right? Usually the well is right there.
I wonder though, if that's bias in what we're noticing.
Yeah.
Because if it's just leaking
Pure
some
methane,
methane,
yeah.
Right.
we know, I think Joe told about a well that was in a low spot and it filled up with water. It was like a grassy area or something and that was bubbling, but you wouldn't see that. you're not gonna get a complaint about that, and it gets back to my sense that those couple of years old wells, that we just might not have that good data on it. I don't know.
I think in Wyoming, we generally, if we get a complaint, it's usually got some sort of fluid at
Yeah.
the surface, but we're a little bit different than the East Coast. Our vegetation's stressed all summer long. because of that. Moisture, so sometimes maybe if there's something growing around the well, it might actually be an indication that.
You do know, like, you got, dissolved methane, or you got methane in people's water wells. I mean, you occasionally get that brought up.
I was gonna say the same thing, but that doesn't often tie to orphan wells, right? Like it's just people detect methane in their water. We go out and try to determine whether it's thermogenic or not.
The, the thing about methane, obviously, and Colorado's no stranger to this, but like in climates where you have frozen ground, obviously methane be coming up to the surface, channeled through utilities, backfill, septics, cracks in basements, and those kind of things show up, and they're not always pleasant when they show up. Explosive.
Okay, let me do a bit of a, where we are, we have a little bit of time left in this session, and kind of as a kind of ramp up to it, there's if there's other kind of input and maybe from the states, we'd like to hear it. What I'm kind of thinking, because we've talked a lot of different places, and as we were reminded, we were posing numerous questions all at once, partly because we're struggling a little bit with where to go with this ourselves. I think what I'll do, and this little heads up for the committee, maybe each of the committee, if you have like a quick succinct statement or questions that you think will be an area of follow-up that would be useful with the states, that we might, because I don't think we have a lot of good ideas, good direction. We're gonna take it back and work this failure issue. But I have this feeling we're gonna need to plan a little follow-up session once we get some of our ideas put together. And I'll restate one idea to start to give our committee a chance. We'll go around the committee. They can throw a little, again, succinct and for everyone. And then we'll, any final comments from the state, then we'll take a break, and we're gonna come back and talk a little bit about this afternoon's about monitoring then. So one of the things that we've again talked about is part of our separate chapter is we have a chapter looking at, well construction, because that relates, and we have a chapter looking at plugging practices and again, different areas of failure. So we'll maybe get some of those together so we can make sure we've identified those. But I think to help explain those, we are going to be looking for, that's where some anecdotal issues. And we will probably come back around and maybe, this kind of failure, can you guys help us out so we can help tell the story of why not to sensationalize or anything, just to give kind of, maybe it helps develop the schematic that might go with that section. So anyway, that's my question is just asking you to be prepared to come back to help us kind of look at those and explain that. And now let me see, I'm just gonna kind of go around the table here. So Adam.
Okay, I have two, but they're very short.
Okay.
One is, is having an inspector present at an orphan well plug job as important as I think it is? And the second question is, what would be most helpful in this report for you to do your jobs?
So let's do our questions and you guys take, and then we'll do a little, opportunity for states to respond to any or all. Missing anything?
So, and I don't need an answer, maybe it might be something we follow up to is, things I see in the report, in news articles, is that from the first round of funding to the second round of funding, things have slowed down on the where there's been more stipulation requirements. So since one of the tasks is policy changes or regulatory considerations for the Department of Interior. You know, what are those specific requirements driving the increased costs and not being able to plug as many wells as you could that you see might be low value, and whether that's the monitoring and things like that. So I think it might be beneficial. We can look at it and see, you know, if that's something that would be published in the report.
Jim,
In your state databases, on plugged well, is there an ability to, merge like, API numbers and see if there are two different or multiple plugging dates that indicate a well has been replugged? That, you know, we could, you know, grab that data and at least have a perspective of this many wells have been replugged, if that's even capable.
okay, Greg?
He was speaking to it earlier, is just in your wells that you have currently, short term seems to be our view, right? So instead of going long term, look at short term on plugs. You mentioned that you've seen some, plugs have gas migration around surface, different issues that are in the short term immediate. You don't obviously get off the well until they're done, but how often do we run into those problems? And what, by your all's opinion, in different states is leading and contributing to those factors?
Jeff, my apologies for calling you.
Greg, Jeff with the G.
Now I need to focus on Jeff, and I'm not gonna be calling you Greg for the rest of the study.
It's better than my English teacher who called me Geoff, so all right.
So Tom, you get to play both sides of this fence.
Yeah.
If you want, and you can pass if you want
Yeah, I
to.
don't think I have anything else.
Okay. Let's see, who, Maleva?
So like if you look at those instances where you get reports from the community that there are issues either at the surface or in the drinking water, if you could maybe link to the three most frequent causes, like is it related to water injection, EOR, fracking? What would, again, this is not to kind of commit you to anything, but just something that will help us sort of direct our attention when we're looking for the failure issues or what is causing these failures, so we can dig in a little bit deeper. Thank you.
Nathan?
Yeah, I certainly empathize with the issue on tracking failures. I spent a lot of time in my career.
Nathan, can you get closer to your mic again?
Yeah, I spent a lot of time in my career trying to track drilling failures, and we hardly ever had any because no one really wants to call anything a failure, and the most common cause is other. But the question I actually have is about prioritization. One of the things that we saw in the workshop was a much more similarity between the state's regulatory approaches for P&A than variability. And I think that's probably the case for how you prioritize the wells to be plugged. And I'd like to know what those processes are, what those procedures are, and if there's anything you think might improve that prioritization process.
Did I miss anybody on the committee? Eilish. I did miss somebody.
Yeah, thank you. I do have a quick question. What tests or experiments or requirements would you want to see to approve new technologies or like materials, technologies, things like that?
Okay. committees of that. Now we're gonna do a round with all the state folks here to wrap up this session. So if the folks online, if you wanna speak, so everybody in the room, we're gonna go around the table, okay? But in the online, if you could raise a hand, that would be helpful. But why don't we'll start down here and kind of go back the other way.
You want us to answer all those?
Yeah, no, well, well, no, because we have about 11 minutes, so let's just pick some part of that you feel is most important to answer and respond to. We will capture all this information and it'll help us give a base to come back out, so.
I think Adam's question about what is the most important finding of this report for us is probably the most important question, but I don't think I'm prepared to answer that right now on the spot.
Okay.
I kind of want to listen to what all you're doing here in the next 2 days and give you some feedback on that. I did text our database person, and yes, we do know if a well was plugged and then replugged, that is captured in our database. It's not in the public facing database, but we do have that. We did, I guess I could answer a question about the new technology. We have had people approach us about wanting to use additives to cement. And we have worked with a couple of labs in New York and designed sort of what tests we want to see. I do have that information about what we've asked for in each of, thinking of 2 cases for additives. To my knowledge, neither proponent went through with the testing. We never saw any results from it. But we did design a study protocol for each of those proposed additives, and that was something we wanted to see how it performed before we entertained actually letting anyone use it. I can't remember the rest of the questions.
And you can, yeah, as much as you want, we actually have, I think we have plenty of time this afternoon session, so we can
Okay.
continue on after the break with some of these other conversations, if that's useful.
We wrote these all down, so from a Michigan perspective, you know, we can provide you appropriate person with an email as follow-up, but most of these are yes, we can provide all the things. Inspectors are very important. I mean, we aspire to be out. We did 24,000 inspections last year on, you know, we've got 16,000 active wells in Michigan, so, but we prioritize, cementing operations and drilling operations and plugging. So yes, we believe that it's important to have a presence. We think that in presence, keeps honest and et cetera, however that saying goes. We think it's important to go take a look at the records, make sure there's cement returns, those kind of things. So we personally invest in that, but our orphan well prioritization matrix, I mean, that stuff's available. We can line these out if you're interested.
I won't cover anything Adam just said, so any policies to remove, there's nothing that's really a big, I mean, there's award conditions that are hurdles for us that slow things down, but like the methane stuff really doesn't cost a ton of money for us to do. There's nothing, you know, the monitoring aspect of that, I wouldn't consider that a huge hurdle.
We should caveat that too, because like in Michigan, we've got 450
Right.
orphan wells, and so for probably $500,000, we were able to do all the things, and we actually made that investment ourselves. But you know, we're not speaking for all the states, because when you translate that to a state that has 100,000 or tens of thousands, then their priority is a little different, because they see wells that they could have plugged with that money.
Right.
But one thing beyond that, you know, that does affect the number of wells we do is the Davis-Bacon prevailing wage stuff. Obviously, that reduces the number of wells that we can plug. Takes up more of the money. And the pay and all the certifications and stuff that goes with that, and just the wage rate increases of what they would normally get. And then I guess I will say plugging priority, I guess I'll hit that one. Yes, we do have a plugging priority plan. You wanted to know what the plugging, I can't remember what was it asked, what the plugging priority is in Michigan. We do have a priority. Every well gets scored. We have a standardized form that you go through that has all numbers of criteria on it that we look at when we move the wells to the orphan list. Depending on where they go on that checklist, you get so many points, it adds up, and then you can get, you know, the higher the score, the more risky the well is, if you will. And the more risky it is, technically, we try to do that one first. And anything that would be leaking, you know, kind of jumps right to the top of the list.
I think that most of us probably started with IOGCC's scoring rubric and modified it from there.
And modified it over
So
time.
that exists. That's something you can look at.
For time to some.
Yeah, I mean, I think a lot of my comments would echo what's probably been said. I think inspections are an important one for us. We've even taken it as far as we actually set up our projects. We don't hire, we don't hire a service company that says we'll do full project management for you. We'll go out and do all this stuff. We write our own plugging procedures for every single orphan well we plug. We plugged almost 7,000 since 1994, and our engineers have written every single one of those procedures and done the research on how it should be plugged. What do we know about the well? How are we going to address the issues in that specific well? We don't have an inspector present during the entire process. We put out all of our projects for bid, hire the contractor, do all that work. But then, we have to prioritize then what portions of that plugging process do we want an inspector present for? And it's the setting of a bridge plug, it's the setting of the cement, it's tagging, witnessing the tagging of those plugs, those kind of things. If they're pulling pumps and wire and tubing and some of those things, we may not always be present for some of those, but we'll be present before they, to ensure they're at the bottom of the hole, if that's where they need to be, or wherever the procedure said they are. So that one's a very important one for us to have the control over that procedure and that job that's going on. Maybe the only other thing I'll talk about that might be different, or maybe hasn't been mentioned yet on some things that increase cost and, may not really have a value or as much a value as others. I guess in my mind, the prioritization of plugging the wells has the most value. So some things that might be done that would reduce the number of wells that could actually be plugged with the money is where I'd go with that. And, one thing I think there could be that downhole monitoring. How are we going to do that? In my mind, the only way to maybe do some of that is to drill a monitor well and go out and do long-term monitoring. And the cost for that could be as expensive as, or more expensive than plugging the well itself. And how many wells are you going to reduce, and can you even get access from a landowner to do it, and those kind of things. So related to that, a technology of, are there other technologies we can do while plugging that would allow for future monitoring without that intrusive monitoring one type scenario? Are there, we see some of that, I think, maybe going on in Class 6 world with fiber optic and some of those things that they're looking at. Is there some way that those technologies could go to the plugging procedure to see if there's gas migration or other things going on down, or water migration?
I think I will pick up, and I've already shared this with our friends from Interior, that the Endangered Species Act and National Historic Preservation Act is what slowed us to a crawl. I think it's less about the funding. But I don't think I'm telling state secrets right now, or surprising anybody either. In terms of Adam's question about what's most helpful to do your jobs, I've heard two different themes, I think, in this conversation. One is, how do we give the public confidence that the money that they're investing is going to hold? That's a very different question than, are we using the best technologies? And so depending on which of those two you want to answer, I think that which of those two pieces you want to explore, my answer would be different about what is most helpful. Giving the public confidence would be incredibly helpful in Colorado, because we seem to be a very mistrustful state, it seems, of this. Which is why we've had the opportunity to really explore the use of biochar in well cement, and that's been complicated and worth having too many cocktails to talk about instead of talking about it here. But functionally, I need to know that the best of the best would support a change in technology, right? It's been vetted through what you can do in, you know, the pristine testing environment to feel confident that we're gonna replace something that does appear to be successful most of the time. Again, anecdotally, but there's a lot of, like, there aren't very many failures, so, happy to help on other things. Jim, you probably know better than I whether like our database can actually spit that data out. I think again, it's gonna be a data quality question when you think about wells that were plugged and as our data systems move and change over time, what we can capture and what you can pull from them aren't the same.
It's just the different dashboards that have to work, or
Exactly, right? And like something that might have been plugged in 1950 may not be captured in our system, so it is a replug, but we don't know that. So, I think, other than that, I think I would mostly have to get back to everybody. Yes, we have a prioritization for orphans, and environmental risk is our number one factor, followed closely by risk to people. And happy to continue now. I think that's kind of a pretty good matter.
So to first answer Adam's question, OGI on location is important. I think the most important inspections is probably the pre-plugging inspection and the post-plugging inspection. Pre-plugging inspection, you're gonna see, you know, if you have any annular gas, what type of issues that you have before you even rig up on the well. You're gonna have the right procedure that you could address that properly and, you know, not be as surprised once you start plugging. Post-plugging, I think it's important to check the well after it's plugged, before it's cut, capped, buried, whatever. In Pennsylvania, we try to leave, and our regulations allow for this, we try to leave the wells that if we ever do need to replug the well, we're in a good position that we have the surface casing there, we have access to the well bore, the shoe plug is 50 foot above the casing shoe. We could run it with the camera, examine it, if it's leaking, drill it out, reevaluate, and then just keep knocking through plugs and evaluating accordingly. So I think pre and post is more important than anything. Prioritization, our system, we use similar to Michigan. We have a scoring system. The inspectors go out, they have an app. It's basically a 100-point rubric. We have a list of really high scoring wells. Anything over 75 is, you know, something that we want to build a plugging contract around. We'll take a key well, and then while we have a contract in the area, we'll do like a 20 well package. We find that 20 wells is the sweet spot for contractors. And again, I think it's like the key well is a priority in terms of what it's doing now. This is my opinion. I think the time to plug a well is not when it's leaking methane or oil. I think it's when everything's perfect. You know, that's when it's going to be cheapest, and you know, you fix a problem before it happens.
Okay. Can I just highlight a point? I'm not on the committee or the states as well. I'm attending on behalf of like Darcy Partners, it's a consulting company. So basically, we have been in conversation with a lot of regulators, mostly in the Canadian region as well. So surface casing vent flow is a pretty, like, we have tons of wells in Canada as well that are facing similar issues. So the scoring sheet that Joe mentioned is a similar one that AER, the Alberta Energy Regulator, has been following as well. But they kind of like phrased it around 5 challenges that they mentioned, or they can at least mention like some of these plug, the failure or the well plug failure has been facing. So one of them is about the material itself, that it's not able to bond to the casing or the cement and the rock. So that's one of the major challenges. The second one is about the application itself. Some operators follow small incremental application, whereas like there are others who follow just pumping a large big slug because of the time constraints and the cost reduction. And sometimes that's not beneficial in terms of the barrier performance itself. And then coming to the leak path detection, like currently the traditional cement bond logs that we have are not to a resolution that can detect the micro annuli that's less than 100 microns. So I think that's one of the major challenges that's also faced. And then most of the regulations mentioned to get the cement or bonding material behind the casing, which is very big challenge as well to get this by different techniques. And the last point is about the long-term integrity, which is about monitoring this, as you mentioned about like having inspectors. Also, some of these solutions, like the materials should be like self-healing. So yeah, I believe that like these 5 challenges were kind of like highlighted based on the discussions we have had with some of the regulators in the Alberta energy regulators, and just wanted to bring that up to the table as well.
Thank you. Online, Paul, I wanted to give you and I think you're our last regulator on here, but unless I've missed anyone, but Paul, did you have anything you wanted to add?
Not really.
Okay. I know we're pleased you're participating online, didn't want to leave you out, whereas we did
Okay.
around. Okay, we're gonna take a 15-minute break, so we'll reconvene. It's 3:35, so we'll reconvene at 3:50. And we're focusing on what I mentioned this afternoon on monitoring, and I know we talked a little bit about that, but we're gonna spend a little bit more time on that this afternoon. And again, I think we have time if there's any of these issues we want to revisit. So anyway, so we'll take a break now for those online. 15 minutes. We'll reconvene. Klein, so I think it's good that we took a few minutes to do that. Let me find my, I guess I should turn my stuff back on. Got it. So what we chatted with Sam and Noel, we're scheduled to end at 5:15. We thought we want to make sure that we don't have to, I think everybody will appreciate not having to wait for a shuttle to arrive. So we actually scheduled the first shuttle to arrive at 5. And they'll wait, but we just thought that we'll kind of target getting this wrapped up around 5 or just immediately after, and then the first group can head back that doesn't have to tidy up our materials. And I think because we actually started talking a little bit about this monitoring topic, and this is just to give you the frame of reference, and I'm kind of, so Mary Kang, who's with McGill University, is leading that effort for our committee, and she unfortunately is not able to be here. And so I'm gonna lean on a few of the other committee members that are working that topic, because I'm not as engaged in that, but I do have a list of some questions from Mary, which is useful. And is Noel, who on the committee is working with Mary on that topic? Because maybe it would be useful for someone to kind of tee that up, and honestly, I'm sure anybody else will do a better job than I will on that in framing it.
Yeah, I think in the monitoring chapter, Tom, are you on that
I
one
think
as
so,
well?
yeah.
Let me pull up and see who else is on there. Apologies. Yeah, so that's Mary, Nathan is on there, Tom and Eilish are in the monitoring group.
So is
Eilish,
are you available to kind of tee that up for us, and maybe Nathan add to that?
Sure. I'm not as well versed in monitoring as some of my other colleagues or maybe others on the call here. So yeah, if I miss anything, just let me know. I was trying to bring up our outline. But yeah, we wanted to explore monitoring techniques. Let me get to the outline here. But surface monitoring, and so we discussed this morning too, to privately, like to make sure that we include subsurface, like post abandonment monitoring, looking at like methodology, methane emissions, like well integrity monitoring, and so the DOI desired outcomes for this are, for anybody that was maybe not part of the first session that we had, is the perspective on whether governments and industry should monitor wells after they are plugged, and if so, recommendations for post-plugging monitoring approaches or risk mitigation strategies. And similarly, perspective on what type and level of post-plugging public disclosure may be appropriate. And I think for us too, we want to establish what types of monitoring options are there, how frequent you would want to do that after plugging. And I know we don't have anything here about pre-plug monitoring, but I think we might want to also consider that too, so that we have a starting point from where we started with emissions, and then post-plugging, how that had changed.
Thanks. Nathan, do you want to add anything?
Yeah, I think in terms of the monitoring, the general things included, obviously, some things related to emissions, methane leaks, fluid leaks that get to the surface, and fluid or gas that might impinge on water subject to USDW. There are other monitoring issues that are probably not going to be things we would want to pursue that deal with, it's entirely possible that poorly plugged wells or even well-plugged wells over time deteriorate and there's communication between downhole zones that say have subsequently been pressurized or depleted and there's flow downhole. We don't think there's going to be much room for monitoring those. Those failures, such as they might be, will likely go undetected unless they appear in the course of, oil field operations or carbon storage operations or something like that. That's the scope of the monitoring issues we were looking for, what people were doing, and perhaps is there a set of characteristics of a well or the geology or the reservoirs that would suggest those are better candidates for monitoring. Those are high priority monitoring candidates, whereas these other kinds of wells, the chance of any significant leakage or failures is very low. So we would only monitor a very small number, if any, of those.
And I should say, if I just to clarify, this would be post-plugging monitoring, not monitoring wells because they've exhibited a problem. And I think we had some conversation earlier that is, and I think it's a fair position if the states feel like, well, gee, that's not a productive use of time. And I think that's useful to know. And we had David and I were kicking around some ideas earlier today, and maybe we'll share those and get your input on that. But any thoughts just from the states on just the value of post-plugging monitoring and what's needed? And I know we talked a little bit, but there isn't necessarily a lot of other than immediately after, reclamation standpoint. But anyway, maybe we'll start with that, and then I'll go into, we were kind of thinking about some creative ways to get some data on this, but that maybe David and I can piggyback on and get your thoughts on.
I guess I have a thought I would just throw out there. This is the old question, right? Is the juice worth the squeeze, right? Going to look for some of this stuff. Nathan hit on the head, let's say there is some deep gas migration crossing between formations. That would be extremely difficult and expensive. As Tom talked about earlier about drilling, you'd have to drill some sort of monitoring or something. Is that worth the squeeze? Is all of that worth, if there is a little bit of cross gas between formations because a lower plug failed? If an upper plug fails and it's in the groundwater, of course, that's an issue that would need to be resolved, and people would begin to see that in their water wells or different situations like that. But of course, then if that did happen, we would address that, right? But also, I think it's important to keep in mind that the vast majority of wells that are orphaned because they don't have economic volumes of oil or gas. There's just not that much there. So when you're plugging them, I think you got to keep in mind the situation as to why they're being plugged to start with. And then again, think about it in its entirety, could we go find all that information? Yeah. Should we? It's debatable.
You'd wanna maybe do a little bit more science. That's what we were kind of thinking about too, as he was talking is, did the original field even have associated gas or significant associated gas? Because when it was, produced out to depletion and left abandoned with low bottom hole pressures or watered out and there was no real associated gas, what would be the value of doing that? Like really going to look for methane or something?
Yeah, well, if it's a water drive, instead of gas drive, there could be very little daily gas.
Other thoughts generally? I don't know. Yeah, I'll share, so, I'm sorry, go ahead.
This is one thing to keep in mind, at least from our perspective, is we don't necessarily have right of access. So you're talking about a right of way effort to get back on the property. People can say no. We wouldn't be able to get on there, so. That takes a lot of effort in our well plugging work anyway, is arranging for access.
Well, I'll share one of the things that came up and I'll maybe ask David to clarify, make sure I capture this correctly, but we were talking about, you know, kind of, especially on the subsurface monitoring side, that are you monitoring because you want to figure out that there's a specific issue in that site? Or do you want to do monitoring to make a broader finding that your plugging practices and materials are being effective? And which is two different ways to look at it. And there are cases where industry is working on projects where they put in monitoring wells and other mechanisms because there is they have a specific real concern that they want to make sure that there's no leak at that. Their reason for doing it is the first thing of making sure that site doesn't have a leak. But the question is, could you find enough of those sites to actually use them as the basis that you could make a determination that, gee, industry confirmed at that site that there aren't any leaks, and therefore you're drawing a conclusion that those materials and practices are effective. I don't know if that's if that's a correlation you make, but that's something we were kicking around earlier as ideas to figure out how do you have data without going into these, I mean, the expense is already made. Can you use existing sites to draw those conclusions?
And I would say potentially, yeah, but I would also be careful with that because we brought up a little bit earlier too about just naturally methane in drift or in groundwater. In Michigan, it happens quite a bit and it's been documented way back since before we drilled the vast majority of our natural gas wells. Just the nature of our geology, we got methane bearing formations that are subcropping directly into the drift. There's nothing there to cap them, so it just naturally bleeds in there. And when somebody comes and drills a well, now they have methane in their water, and it's all along the margin. We know where a lot of those locations are, and we get calls on that. And let's say an oil well was there and was added later. Well, yeah, all of a sudden right now that's easy bait to say, okay, this well's leaking into here, but no, it's not leaking into there. This was, you've got this formation subcropping since, the last million years bleeding gas into the drift. So I would just say be cautious kind of with that approach.
Okay. Fair enough. My gut feeling is it was maybe a bridge too far, but it was kind of just a. I think the committee kind of feels drilling monitoring wells to check all that is not.
You ever anticipate like maybe a second round of survey, like as you're thinking about these questions? I mean, you've got a small population of orphan well, oil and gas regulators here, but as you fine tune your questions like these, they're pretty good and pointed. Be good to put some thought around them. I don't know what Tom thinks about that. He's sitting in both chairs, as you noted. Do you think there's value in that or no?
I think there's value in getting more participation from the states because the states are the ones that are involved in every well plugging, whether it's an orphan well, whether it's just operators doing it. So the reality is the states have the data. And I know in this regard, there's few states here. It just didn't work out that many of them could attend. I think states need a little more heads up that things are coming down. They need more time. They need to plan. They have approvals and things to get. So the big states, Pennsylvania's here. And so that's important because of the number of wells they have and probably the varied wells they encountered because of the sheer number, the scenarios that they find in those wells. Texas obviously would be important to be able to talk to, and I think they're willing to do that. It's just trying to coordinate with them to get a time to do.
And it's kind of sometimes hard to boil these things down into like a single question on a survey that I'm kind of thinking as we get things farther along, it may, even if it's a virtual session, it may be in, you know, maybe it's just an hour or two virtual session to go over some of that. It would probably be a public site. We would need to make it as a public information gathering session, but I think it would allow us to get the nuances of the conversation that you don't get in the responses.
Yeah, and I think if we could send some questions to set up the conversation so they know what we want to
Yeah.
talk about, so they can be prepared, so they feel comfortable that they can answer those questions, you know, that they have data or that they have the knowledge to have the right people. And then go in and do a virtual roundtable type session, I think would be helpful, you know, then. You know,
Yeah, that's a good, I think it's very, yeah, I agree. It's very useful to set, you know, get the background and get things organized to the extent possible. But I just know from, you know, looking at the responses and trying to, you know, I got a flavor of it, but this has been incredibly helpful to have this discussion.
It's hard to get the nuances in a response, you know, they could write 10 pages about some of those
Oh, yeah,
questions. You know,
exactly,
so that they can
exactly.
explain the exact scenario, so having these open, just roundtable open conversation is much easier to try to help frame the scenario that they're talking about and the situations that we encounter.
You got a couple states here that have coal bed methane. Michigan doesn't have coal bed methane. We might have a shallow charged like Michigan Stray, some shallow zones that are naturally charged up with methane that may play into this conversation, but you know, like Michigan, we don't have charged up overpressurized or pressurized disposal zones. Our disposal zones still take water on vacuum. So I mean, state to state, and that's what we said all along is, you know, I mean, it depends. It depends a lot on geology. It depends a lot when you get in the hole. So appreciate the conversation too. It's really good knowing what you guys are noodling on.
I think some of that, Adam, even, you know, going back to the July meeting, I think that was a very good meeting that, you know, a lot of states attended that, and I think we're able to portray that message of, you know, it's not even necessarily a basin or a field. It can be a well specific issue that you have to deal with. So every one of these wells could be slightly different. And you have to really do a well by well evaluation before you go in and plug there. And so it's really hard in a report. And I think I had these comments in that meeting. It's really hard to try to do, you know, like a national standard or even a statewide standard or even a field-wide standard, you know, because you just encounter a different scenario sometimes in every single well, even though, you know, it's a quarter mile or something from its neighbor that you're plugging also.
Well, sometimes it could be in the same
Could be the-
well. You might be drilling a straight hole and you would encounter a lost zone or something, way how, and it becomes a lost hole and you plug back and you're still in the same well bore and you literally sidetrack and have no issues. And you're 25 feet away from the original borehole. So, I mean, I don't know how you can have it kind of.
We may change county by
Everything.
county just because formations are lensing out. I mean, the geology itself is changing almost by township or county.
I ask a very quick question. So based on the monitoring or the historical and current monitoring of these wells or the wells that are filled, so are there any changes to refining the plugging standards, like any learnings that are carried over from some of these historical wells, maybe the root causes?
Okay. Like we alluded to before, we're not seeing failure in ones that were plugged with cement. We're seeing failure in wells that were plugged with heavy pit mud, fire clay, trees, other material, whatever they used back in the 30s, you know.
The reverse things can be true though, like the challenges you encounter in drilling, like say from township to township or county by county, because the geology's changing is informing how you maybe need to take a certain casing deeper set plugs, you know, to a deeper formation. Because maybe there is shallow stray gas, you know, sort of the reverse things can be true on plugging legacy wells where you know those conditions are true too. So like on final stages of cement, you don't end up with gas cut cement.
You know, I mentioned that Mary, who's leading this, had put together some questions. Her questions are very specific. And I think they would be better dealt with if she, you know, yeah, I don't think it's productive for you guys to answer like whether it's, you know, who has jurisdiction over groundwater in your state or but one thing generally, and I think this is pretty well true, all the states now have a really good good data on your groundwater zones and what level of groundwater protection you do. I presume that was one of her questions on, you know, some of the details, which she needs for this, will follow up, but is that a good determination? I partly knew that because when I worked for the state of Ohio in the mid 1980s, we were finishing up maps for groundwater mapping so that we could delineate all that. And if Ohio was doing it in the 80s, I presume other states that already were doing that too.
I think that's correct. I mean, I think it's correct in Wyoming, at least specifically that I can talk to. You know, we have zones that we know are the probably the deepest usable water, you know, and in the west, we have some zones that are fairly deep, you know, that we protect, you know, 7,000-8,000 feet deep that are that we're protecting for the future potential use. Maybe not always drinking water use, you know, quality, but pretty close to it. And, you know, potential future treatable water or industrial use water, other things like that. I mean, we have some zones where there's 15,000 feet and the TDS is 1,000 parts per million. So, you know, obviously that's a whole different ballgame where we're producing oil and gas above that zone. You know, so we're not even encountering it technically when we're in our oil and gas wells. We're encountering it when we're trying to go that deep for disposal to get below the freshwater zones. But I think most states have those standards that they set, maybe basin wide. Wyoming generally it is, you know, our Powder River Basin, we generally protect Fox Hills, which could be between 5,000 and 7,000 feet deep. So historically, when a well was drilled, it may not have that protection. So we go make sure that there is cement across those zones or isolating those zones when we go back to plug it, you know, because in the 40s, 50s, 60s, they maybe weren't concerned with protecting that zone when they drilled a well. So we're making sure we do that now. I think it's probably true in most states.
I think so. Most states are gonna know whether they have, what their base of freshwater, base of USDW is, and they probably have rules that relate to that in terms of setting of surface casing and cementing. In addition to other work, you know, to understand quaternary geology. Michigan's a little unique. We don't have that situation that Tom was talking about. I mean, our freshwater generally ranges from like 200 feet, maybe down to 800 feet in some instances, but when it starts to turn brackish, I mean, it turns salty fast. It's a pretty bright line for us in terms of USDW. We've never had aquifer exemptions, for example.
Yeah. David, you.
Yeah, I guess kind of what I want to just confirm is what I'm taking away is the general consensus is plug well failures by and large in the grand scheme of things is rare. It's a handful. And even when it does happen, we can pretty much attribute it to poor plugging practices, which is why we have since strengthened plugging practices today and going forward. And therefore, when if that rings true, and whether you call it anecdotal, whatever, we do have enough evidence to help support that finding. Take that into the whole plugging, you know, post-plugging monitoring requirements and what's enough or not. So you could take it as, well, if you have a well, certainly a well that does not exhibit any issue, and you plug it textbook, everything goes right, that's probably not a good candidate or good use of money to, continue any further monitoring to learn from that. We have enough evidence to suggest that's probably the lowest, least risk of future problems. But maybe a well that has exhibited leakage in its current state, and that's why it's on a high priority list to get plugged in most cases in your prioritized catalog. And whether you have issues or, I guess what I'm trying to go with it is is there any real necessity for monitoring post plugging, or what is the good sample size, and for, should it be really just the ones that are problematic that we've already seen exhibit leaks? So maybe we want to keep a closer eye on that for a little bit more than a day. I don't know. That's where what I'm trying to get to is what is post plugging monitoring, surface or subsurface? Because what I also heard too is from a subsurface standpoint, obviously nobody really wants to drill a bunch of monitoring wells and all that, but are there cases that should support doing it for, like what I've said, wells that are already leaking? Perhaps we may not, even if we elect to monitor those for emissions, we're not really looking at subsurface, what could go on. So
have you received testimony that kind of helps think that out a little bit? Like in terms of, like, let's say your cement plug to surface, how long and what kind of readings would you expect from, like, if there was any in-train gas, not necessarily direct connection, but some in-train gas bubbles in cement, for example? How many days or hours would you expect for that just in the near wellbore to still be measurable versus a channel cut cement that's maybe not significant or huge, not easily detected, but how many days does that show up, and what kind of range is that? How much of a range is actually a problem? Those kind of things. I don't know. I haven't followed everything that you all have done. What kind of other expert testimony that you've received from service companies and things like that, but to answer some of those questions, to figure out the juice worth the squeeze or diminishing returns and things like that, it seems like if you're thinking longer term about what best practices might be offered, like weighted data cap, or what I mean? It should be informed by experience and science, maybe.
I would go one step further if I could real quick and say, I think your scope is still too wide and you need to narrow it down, because you keep saying leaking orphan well. Well, most orphan wells haven't been plugged, right? They need to be plugged. And a leak, if it's coming from the wellhead or a valve or whatever, and yes, it's a leaking orphan well, but that's to be expected. It's coming up through the casing or through the tubing or through whatever. That's different than, you can't just say leaking well. It's gotta be like, you gotta narrow that down. You leaking outside the surface casing, leaking, like, where's this leak that we're worried about that won't be fixed when the well is appropriately plugged?
no, absolutely. The leak path certainly matters, right?
Yeah.
And I don't know if we get that granular. And is that I'm speaking broadly terms because that's kind of, from what I can see, is how DOI has categorized them, right? You have unplugged and plugged, and two types of orphan wells, but we're measuring all for current
Well, and then
emissions.
there's documented and undocumented too, and we've hinted to orphan well, like, okay, we don't suspect we're gonna find many undocumented in Michigan because of the record keeping. But as I said before, where we have had instances of a mud plug letting go, do we wanna use some of this funding to look in those areas and say, why did that well fail? It was plugged in the sixties with heavy mud. What other wells are in that field? Why might have done that? And do you monitor those? And does that become all of a sudden a documented orphan well? And, I think the orphan well program in conversation is like, well, we're not I don't know that we're ready to go to like, you know, going back in and replugging every mud plugged well in the United States, cause you've got documented orphans that have never been plugged.
Right, yeah, you know, you kind of chalk it as, you know, for those, unfortunately, you wait till there's issue presents itself and then we respond versus, you know, I guess where I'm going is it needs to be targeted monitoring programs that are based on risk, more so than just arbitrarily 5% at random, you know, for whatever reason. And to your point too is, 'cause that's what's so hard is like, is it because it came up the tree of the production casing? Well, obviously, we're gonna go plug that, so that's an easy resolve those issues. But when it is in the casing or surface casing and things like that, and if we don't fix it during the actual plugging program, that's not good. That issue doesn't go away just because we cut and capped it. And those would be, you know, maybe those cases that, you know, and when you just say that's a leaky plugged well, it's a very specific factor that, you know, mechanism that's causing it. It's usually not up the main wellbore. I would say it's up through channel annuli, and probably because the primary cementing job was poor to begin with. So I agree. It's slicing and dicing an entire country worth of wells that are in different conditions and construction. But right now, from what I see is from the DOI, they recommend almost like just, you know, kind of arbitrary or generic monitoring timelines or timeframes. And maybe that's what I'm trying to get to is the broad consensus around state regulators is probably that's not, we want more targeted based on some risk means.
And I think
And access, of course.
clarifying that it's post-plugging.
Post-plug, yeah.
Post-plugging monitoring, so, cause it's very easy to get into this broad
I feel like
discussion of monitoring, and that's not what we're talking about.
random statistical choice might still be your best option, though, I think. Like, again, targeting leaks, I could have a well on the left and a well on the right. The well on the left is leaking right through a valve, and this one on the right's not, right? Well, this one's got 100 pounds of pressure on, this one's got 1,000. So this one just happened to have the bad valve, right? But we're gonna prioritize that because we saw a leak on this one. I would say the other one is of more concern because of the pressure. I don't know. I just think by looking and saying, okay, we were able to measure a leak at this site isn't necessarily your best way of going about deciding that's where I want to continue to.
Yeah, and I think if we're talking about, you know, current plugging or modern plugging work or plugging work in the orphan program today, trying to figure out which, you know, that it's different than the old wells that were plugged with heavy muds and, you know, they might leak at a higher rate. You know, I think current work, it's very rare to have a leak. So trying to understand what factors could contribute to that well having a leak. So is it that it had integrity issues in it, or it had, you know, problems with fish in the hole and couldn't get down to the depth? You know, what is it? What are those scenarios that you encounter that you might be able to know ahead of time that may result in a less successful plugging project or plugging job on that well? And then is that one that you should be monitoring and make sure that what you were able to do was adequate?
Yeah.
And maybe, maybe you can't go back and do anything. So maybe that was all you're ever going to be able to do. And so you're gonna have to just let the pressure bleed off or whatever over time and hope that it stops. But I think trying to figure out which ones are a priority to actually do, which, you know, in my mind, it's some of those wells where you can't do your desired procedure on the well, mostly to begin with. And then at some level, you know, most of the time that's still okay.
Yeah.
But when do you kind of cross that threshold of this is a well that, you know, that we would be concerned about having a leak? Where is that point of it's probably this one really may not be okay anymore, that we should go monitor?
Yeah, and I'm like Jim said, I'm clarifying, it's the post plugging. And it's true, is it a day, a year, 10 years? Where do you draw the line? It's so many, it's very arbitrary. So that's just the pulse I'm trying to get in the room.
I do like that you mentioned the deviation from the procedures, right? Kind of what was your plan going into it? And if you were able to follow that plan or not. Because I think that's in a few cases that we've seen recently, it's that deviation from procedures that has led to the failure after the fact.
And for many of these wells, there's a lot of unknowns going into it.
Yeah.
And most of the time, we can figure out a procedure that's adequate to be able to address them, but. You know, then there becomes a point where it would create more concern.
So find something, we often don't follow the plan.
I miss
I
late
think with
plans, right?
Orphaned,
Like,
that's pretty good. That's all.
Catherine.
Changes as soon as you get.
Yeah.
Yeah.
well,
I can't recall an orphan well we plugged in the recent past where we actually plugged it the way we were supposed to. So
So yes, so that was a true statement. that
Right,
I
high
made.
risk, okay.
And I guess what I wanna add on to that is, just thinking like, I'm not in the field, I'm in the office, the administrative part of this, so. We're gonna have problems, our project relies entirely on willing landowners. We don't have permits for these old wells. So people have to say, they have to
Yes,
sign an
yeah.
agreement that they allow us to come do this work. We will have less participation in a program if we make them open-ended. If we say, we want the right to come back whenever we want, and we may or may not set up another rig and put down all your trees again, and do whatever we want for an indefinite amount of time, okay? Sign here. I mean, no one's gonna agree to that, and that will be very detrimental to our program. So I think we need to know very clearly what we wanna monitor and what value that information is gonna give us. Because my sense of it is, as Adam said, that it's not, we're not seeing a lot of failure. But that is just my sense of it. That's not, I don't have data. I'm gonna go back and take a look at what I do know, but it's gotta be worth it to have the program take a hit like this.
Thanks. So I have a sense that plug failure happens usually when you're pressuring up the subsurface or something's changing in the subsurface. So I guess that's kind of a question right there, but it seems like when you're doing a class 2 injection, or you're doing a frac job or something like that, you may want to look at the wells that were in the AOR where you were uncertain about the integrity of the plug job. So do you ever do that? How does that occur?
Do it every single.
Yeah, so then that is kind of post-plugging monitoring that's routinized, I guess would be a way to phrase it. So can you all talk more about that?
I mean, I guess in my opinion, the fact that, and I'm speaking just for our projects in Wyoming that I'm familiar with, we have about 5,000 class 2 injection wells, way dwarfed by Texas and some states, but quite a few more than many states. And we do a lot of aquifer exemption, so we do a really in-depth look at in our program. And we don't have many issues even in that regard, whether it's water floods. And some of ours have been going on for 60 or 70 years, whether it's disposal wells, within these fields. But you do that complete review. Many of these wells in those fields were plugged 50 or 60 years ago, and they're not, pathways for migration of anything that we see. So I think in most cases, again, it's a rare occurrence, even in that scenario where we are pressuring up the formations. These plugged wells are still, the plugs are still holding and not allowing migration. I think you're right, though, that those failures occur when there is a pressure, there has to be a pressure difference to drive that flow of the gas or fluids or whatever it is. But so, I think that would be a scenario that if there are problems, you'd see it commonly in a class 2 or whatever type of injection well you have, but probably most common class 2 because they're going back in many of the same zones that the wells are drilled to.
So before you allow class 2 injection, you do the AOR, you say this one needs to be remediated and that one needs to be remediated. And I wonder if we had could do a database search of class 2 well permits and what wells were required to be remediated, if we could get a sense, if you could extrapolate from that across state, assuming that area is, representative of where there might be issues if there was a subsurface pressure change. But you wouldn't bother to remediate them in the absence of a subsurface pressure change because then the risk of a leak would be low. But that may be a data source.
So again, from Wyoming, I can tell you our requirements to remediate those wells are very rare. It's maybe one a year at most that we find where we're concerned. And we're doing a records review mostly on those AOR wells. We're going through our records to see how was it completed, how was it plugged, whatever the current scenario is on the well. And it's very rare that we ever find one that has to have remedial work done. We don't, and some states may track it better than we do. Our database doesn't allow long-term tracking of that. So what we do is make them fix it before we issue the permit. So it's less, so we have less info in the database than on, you can't have this permit until you fix this, because we just hold the permit till the well's fixed, then we issue the permit, and then the database tracking starts, and so it's a little.
You'd have
other
to be a
states may
pretty
do that
clever
more
data
than
miner to figure that out.
Yeah, we're set up the same way. That would be a huge data dive for us to try to pull that information. That would be very exhaustive for us to try to find.
But I can say it doesn't happen that often. I mean, I can think of maybe 4 max wells that I can remember in the last 14 years that I've been with our agency that we've required remediation on. And I remember one gas field that was proposed for like gas storage or something, and they came in and we told them all the work that they were gonna have to do and likely remediations to do that. I can't remember whether it was gas storage field or reactivating, but anyway, they never came back. I mean, cause that's like, even in the context of CCUS, having well control, a bunch of penetrations is wonderful for well control, but it's not necessarily gonna be a good thing for CCUS, depending on your formations. If it's a deep formation and really doesn't intersect most of your perforations, then it may be fine and well, and you're not looking at much remediation. But you have a shallower zone that has numerous perforations, that AOR and potential remediation become pretty complex.
Yeah, and to take that beyond class 2, when we're writing a plugging instruction for any well, we review that entire well file from the point of drilling to see, is there any downhole considerations that we need to consider? And then we also do that for the wells that surround it. So we're trying to write plugging plans that are going to be incorporate anything that might have happened in that area. A lot of times our area geologists were the ones that were, they're most familiar with that area anyhow. So what formations have produced? Did this well over here have, a gas show in whatever formation? Because then, okay, when we're plugging this one, we're gonna make sure we have a plug here or just above it to keep that in case it shows up. So we try to plan for all that ahead of time for every well.
You do that for class 2 EOR as well. You're not only looking at the plugged wells that might be within an area of endangering influence or review. You're also looking at the other wellbores that are in the area that might stay open as producers. You're producing things, but now that you're injecting things, is it still appropriate, or are things gonna move around on you? The wellbore's construction for the time, it was fine for producing that field. Is that still appropriate for water flood or CO2 injection?
To your question, Adam, I mean, we do that for horizontal development of DJ. It's driving much of the P&A work in the DJ basin right now, right? But what the interesting way to approach it, and I don't know if the database can support it, is where did we see impacts from flood wells that we saw an impact in, right? Conversely, that there was a problem with that plugging job. But I don't know if that's 6 wells, and I don't know that we can track it. But we could look at why are we requiring mitigation in some circumstances, not all, to help hone in on this question.
Yeah, it seems like there might be some empiricism there, but getting it would be hard. Probably too much time for state regulators to do, but maybe some enterprising university scientist or a lab scientist download the data and do it and verify it with you and figure out if it's meaningful, but not necessarily on our timeline.
No, I mean,
I will
there's
say,
2 or 3 researchers.
yeah, on the class or on any of the, well, let me just speak to class 2 because that's what I know the most about. That is a data point that's required to be reported to EPA. So depending on how the state's tracking it, there may be some data there at EPA on that remedial work that has to be done when or let's say corrective action work that has to be done when you're gonna go in with a new injection project or a well. So, like I said, Wyoming doesn't report it the way, we didn't track it the way EPA likes it, so we don't have any to report to them because we get it done before permits issued, and they don't want it tracked unless it's a condition of the permit. So it's a little different depending on the states, but I think some track it that way, and in fact, we will start tracking it that way as soon as we go live with our BDMS UIC system, but you know, that it'll be years before we have more than one or two data set, you know, data points in our data set to say that this work was an issue.
Okay,
I've got another one.
you can do your other one.
Monitoring out of there.
So, okay, so, we all agree that drilling, special monitoring wells is crazy. And so thinking about, you know,
Words.
yeah, thinking about passive ways of doing monitoring using existing things, there's, the existing groundwater monitoring network out in the United States. My understanding is it's not really dense enough to tell you anything useful, and there's a baseline problem. So I don't know if that's a way forward. Maybe it is, probably worth exploring. But I also wonder if satellites, not like methane detecting satellites, because they're not at the point of getting these tiny wisps of gas, but visual satellites where you can compare over time what the land looks like. You can, you know, see if it goes from gray to green in a way that you're not expecting or something like that with machine learning. Some satellites can look at land deformation. I know that BEG is doing some of that work. And I wonder if this is again, a research project that's way outside the scope of what a state might ever do. But it's still worth thinking about as a way to, can we look at this at scale, using existing data sets to see if we can learn anything about incidences that we don't already know. I'm just throwing that out as a thought, not necessarily for any state to answer. Unless you want to.
Any thoughts out there? Any other committee members that want to pose some questions or drive some discussion?
I've got one, and that would be on the wells that you have to remediate for say a class 2. Is it as much as there was an issue with the well, or is it as much as there was a change in practices that now? So I think with that kind of data, doesn't mean the well was bad. It just means it wasn't plugged to the standards that it needs to be today, and it may not be leaking. So
Or it wasn't plugged, it may have been plugged to fine, it's just that they're using a formation that wasn't used before.
I think I mean, for us, that's what we would see as most of our issues. It's
Shallow.
you know, you've got open annulus on the backside where it could allow migration of the new injection to go. You know, and so it was just either a standard that wasn't up to the current standard, or it was the project wasn't thought about, and now it's gonna be an issue.
Yeah, I just wanted to bring that up because I didn't want something like that to be considered a failure, because it's not, it's just a change in practice and a change in operation in the areas that you're remediating. And
Not a failure, but still an issue.
only if you drill a class 2 well. If you don't, it's not an issue.
Yes, class 2, class 6, something like, if you pressure up the subsurface nearby.
Yeah, if you're changing the use of
With the initial
subsurface.
basic design and
Take
abandonment
into
that's in
account.
place.
That's when it's a
Trigger
problem.
to review.
Yeah.
In which you can't take into account that.
But if you're having to do a AOR analysis, then it's gonna be taken care of.
Because it's on the onus of the operator who wants to change the subsurface parameters now.
Yeah, all this is good to get out there and understood.
Okay, I think we're kind of hitting the limit of our input here. And so I don't wanna drag this out, you know, we will. I think it's been a really useful conversation. I have and both for the committee, but hopefully also for the states to kind of, I think it's helpful for you to see what we're kind of trying to struggle with, and we have we'll continue, we have some more topics to cover tomorrow. I know some of you are joining us and some of you can't, and that's fine. I think we clearly will work, and we were just, I think just based on our schedule, just like we have another in-person meeting in Washington DC in late July. And then other than that, we're planning some virtual meetings in late June and sometime in August. And I think ideally the June, July timeframe, I think will be most useful because it's earlier in the process. It's a dilemma. And even if like our in-person meeting, we'll do that as a hybrid meeting, so you won't have to come. But for those that, and we'll try to, our goal tomorrow in our closed session is to figure out what are key things we need to cover in those meetings. So hopefully we can give you all a heads up on timing as we get that lined up. So Missy, anything else you want to cover this afternoon with this group?
No, I think this was really helpful, and thank you very much. And I hopefully some of you will be able to participate tomorrow. I know we're asking a lot of you to spend another day here, and we really do appreciate it. It is very helpful for us, and I agree with Jim. It gives you an idea of what we're struggling with and as we go forward, and we'll probably come back at you and go, okay, so this is where we're headed. So
Can I ask a question?
Yes.
Apologies for not being here tomorrow, we'll focus on the phone, but going back to the question of how can we be most helpful, and to me, again, there's these two themes. One is a technical question, what are the best practices? The second is more of a social science question of how can we give people who are not technical experts confidence that this is a good investment, that these are gonna hold. Have you done any scoping of that question with the people who are like most anxious about this issue?
no, we have not.
Because I don't know how to answer their
Yeah, that's a really good questions. Yeah.
Part of the statement of task was also like considerations on if we were gonna do long-term monitoring, how do you involve stakeholders and what kind of reporting or announcements and things like that too. I will say that I think the one that trumps is the technical side piece of it.
That's great.
And I think what DOI was just saying is the reason they are focused on, what's triggering this is it's sensible to explore how permanent this will be.
Yeah.
Maybe making a broad assumption that the public would care about how their tax dollars are being paid. So it's one in, one and the same, but it may be worth exploring that too.
Yeah, I think framing it that way though, right, the
Mhm.
permanence of it will help with many of the stakeholders who are actually listening with an open mind. I acknowledge that there are some stakeholders beating this drum that maybe aren't in the most constructive spaces.
Right. Well, that's the whole point of this, where I'm going with it, right? I'm,
Wait a second, I gotta record
It already was.
well, it's like it's all handful, it's rare, it's, you don't have to convince me, it's
Right,
the audience of the report
Yeah.
needs to be.
but how you frame, I think you could ask
Yeah.
some of those folks, what information you need, how do you need to receive it for it to land with you?
Yeah.
Right? And so the scope stays the same, but the words on the page, we don't have a gap between
Yeah.
what's
Kinda
being said and what's being understood.
public engagement or
Yeah.
things,
There's probably a lot of people in the US that have no idea what an orphan well is, nor do they care. But there is a lot of people who do.
Yeah.
And it's,
And we don't care until they do, some
Yeah.
do, right? Like,
well,
Well, you see
I have-
one blowout and then
then it's everything.
it's all.
well, I have several pictures that I show when I'm giving speeches to communities. Why should we care about well integrity? And I give my conference speech like, why do we care? Why should we care? On my slide is I got a Macy's parking lot with a well in it. There's several of those in Oklahoma cities.
But you don't do those in Colorado.
Be selective.
Got football fields with a wellhead there right outside the end zone, and there's actually a pump jack pumping, and that's in California. I've got, I took a selfie in like somebody's driveway, there was a wellhead right there, and they would drive around it in the middle of a suburb. And you know, there's all these things, and that's why we care, because as an industry, we care, because social license operates a real thing. In today's world, we don't stand alone. It takes one, your
Everybody
morning
goes-
was ruined today.
Our goal is everybody goes home safe.
Everybody's you know, the way the media,
That has
we have one issue. I P&A'd the old Jackson, Mississippi field. I actually P&A'd that field. Shell did in the 1970s. I just got through with wrote an SP paper on it. But we P&A'd it, and it was 40% H2S. When I was out there, it was flaring green. I was flaring straight H2S. I was in full direct oxygen because I didn't trust anybody else to treat it, so I treated it myself. That was literally 100 yards from an elementary school. And that's what we were doing, unbeknownst to the community. So you know, orphan wells, and like that wasn't an orphan well, but that orphan wells in that area that was done a long time ago can have big problems, even though any analysis wouldn't have even shown that. Because at the time when Shell did it in the 70s, there wasn't that database, right? And there was a lot of stuff in Mississippi, right? And so we're just, you know, how do we show the community that, hey, we got some standards, we got some stuff, this is how we do it. And the biggest thing on the data part is just to show people that what we're doing is good. And by and large, what we're doing is good. Or there'd be so much more issues on the news today.
That's a really important point, and that's why we're hitting this, is we wanna make sure we have a good basis for making these findings, so we can have that, so when people are, if we can make a finding that, look, the problem of these old wells, the new processes, that's all, that is largely good. We want to be able to say, why do we, you know, have the basis for making those findings?
So,
And that's why we're looking at how to do that. And that's the importance too, if we can't, saying, look, these are some things that we could document and capture in the
if we
future.
didn't have
that
good
would help
processes, I
share that.
guarantee you that H2S, 40% H2S field would be we would be hearing already on the news. And there had been a lot of problems. And they were making sulfuric acid out of it because it stopped, it produced so much H2S, they just made sulfuric acid to pipe it directly to a plant. We would be hearing all this all over the place because there's so much old legacy H2S and some of these older wells in over East Texas. My God. So we're doing a good job. We just, you know, this, I think one of the stepping stones we could use it is to just have a documented process saying there's not a pandemic of orphan wells that's going to get you. And I think the intent's not for us to get, you know, it's about how not, oh, we got you, we need to all do better. It's like, we're doing good, how do we show it? That's, I think that's also the intent, and yeah, hopefully it comes up with some money from the DOE and hopefully even more money. But I think that's the intent.
Cameron or Noel, do we have, so quick question, do we need to have the committee stay for just a minute? Is there anything we need to do, or because we are reconvening later, or are we good to adjourn?
We are, yeah.
Call the adjourn.
Yeah.
Okay, thank you again, and some of you will see it. Thanks so much for your participation, your thoughts, your ideas, and look forward to continuing our dialogue.